All righty. Well, hello, everybody out there in all the various places you are. And my name is Brock Dahlman. I'll be your host for the day and also on Friday. And first of all, we want to wish you the happiest of International Beaver Days. Whoop, 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 whoop. I even have my little colony of friends here with me that are with us. And so big tail slap and a big orange toothy grin to everybody out there joining us. We're super happy you're here for California's first ever online Beaver Summit. And today is day one. We're calling it Beaver Essentials. I'll get more into the history management. I'll tell you a little bit about that in a second. And then on Friday, we've got Beaver Dynamics, and we're talking more about ecosystems and restoration. And one of the interesting pieces of this is over our 2 days, our illustrious steering committee, which I'm going to acknowledge here in a second, we feel like we've curated an amazing event for you all, and we've got just a lineup of speakers we're really going to talk about and we're explore with us the many benefits to beavers and those benefits that they offer to the diverse habitats and ecosystems in our varied state of California, which, as many of us know, is this incredibly diverse state. And so we're going to be talking about beavers in mountain meadows of the High Sierra, of the Southern Cascades, talking about beavers in coastal salmon streams, whether that's up in the Scott River in the Klamath Basin, all the way down to the San Luis Obispo area, beavers in riparian rangelands, beavers down in the valley and the foothills, in the wildlife refuges, and even urban beavers. We've got beavers all over the state. And we're super excited to basically let you all know about them and more about them and have a rigorous conversation and exploration around the sense that we believe the beaver glass is half full and more than half full, and want to really share that with you. And our tagline for this conference, as you all have seen who've been on the website, is that climate change is making California hotter, drier, and harder for people and wildlife, and we believe beaver can help. And that's really the essence of being a beaver believer, is really wanting to help and be in a collaborative coexistence with our castor comrades. So I do want to start off acknowledging we had an amazing steering committee of folks who put this conference on. And so Heidi Perryman of Worth the Dam and Sonoma State's Jeff Baldwin are our co-chairs for the steering committee and for today. We've also got the California Urban Streams Partnerships, Jackie Vanderhoot, is the facilitator today. Biodiversity First, Elizabeth Johnson, Humboldt State Master Student Zane Eddy, and then also, and you're going to be hearing from them later as well, we've got Forest Service, U.S. Forest Service's Karen Pope, the Institute for Historic Ecology's Dr. Rick Landman. We've got CSU Channel Islands, Dr. Emily Fairfax. We've got OAC's Water Institute co-director with myself, Mrs. Kate Lundquist, on here. So that's been our committee that's spent the last period of time in this COVID moment of trying to bring you the castor message forward in an online format. And we do want to give a specific special thanks to Sonoma State and just the entity of our public university there for all of the support for actually hosting this event and providing all the logistics and the technical support. We couldn't be doing it otherwise. And FYI to everybody on the webinars today, we will be recording all sessions today, and those will be loaded up ideally by tomorrow. We'll also be capturing the chat, so that will be recorded as well, or the Q&A portion of this. And then specifically related to the Q&A, ideally, all of the speakers will leave enough time at the end of their talk so that there will be some time for Q&A. And what we'd ask is that if you type into the Q&A function, which is at the bottom of your screen, when you go to the bottom, there should be a Q&A button. You can type in your Q&A, and then Jackie will pull out the Q&A and sort them, if you will. And then at the end of that, at the end of the presentation, I'll be able to then ask those questions to the presenter so that they can answer them. So please don't use the hand function. We're not responding to that at this point. Just put your questions in the Q&A there, and we will address them there. I did want to say one thing, just a bit of gratitude in the fact that the folks in New Mexico, the Defenders of Wildlife and Wild Earth Guardians and the New Mexico Department of Fish and Game and the New Mexico Environmental Department had their own Beaver Summit back in October 2020. And in some respects, we are leveraging and being inspired off of their work. And just want to give a shout out to our Beaver Believer friends out in New Mexico, which are Legion. And and then wanting to also just say that we have had, although currently what it looks like we've got is counting as I'm looking at the participant number here, we're for 425 participants in counting. We had registered upwards of 979. So hopefully that number is just going to keep on ticking up. But the point being is there was an incredible outpouring of interest in this 2-day seminar. And of that, what's really fun, and thank you, Heidi, for being the tracker of the categories of folks who signed up. But welcome to all of our California Department of Fish and Wildlife folks. It looked like a whole lot of you guys are signed up, and part of our rationale in this being these 2-day webinar being on Wednesday and Friday during work hours is for those of you who actually are at work instead of on the weekend are able to attend. And so hopefully there's other folks in USDA and NRCS and various resource conservation districts and national park and departments of transportation and Fish and Wildlife Service. We have BLM, National Oceanic and Atmospheric Administrations, California State Parks, Conservation Corps, Water Board. So we are super excited that all of the various federal and state agencies and local county folks that are out there doing the work, supporting this work, getting engaged, oftentimes regulating, permitting, participating with us, funding the work, that you're all here with us. Thank you for that. It definitely, in the essence of being beavers' role as animals that live in colonies. And so the whole of a beaver colony is greater than the sum of the beaver, so to speak. And then I'll let you sort that one out if that's a plural or singular. Beavers. Very interesting. Another fun thing is that as far as the registration went, we had folks from 31 states in the United States, which is amazing. We're loving that. Hawaii, go Hawaii. I'm not sure. We're going to bring back the beavers to the Aopua'a. They might eat your taro a little bit too much, but we're glad you're here. But all the rest of the states have beavers in them. And so, and many of you have beaver programs. And I'm not going to list all 31 states, but we're happy you're here. And then also, we welcome folks from Canada, and we even got one Spanish beaver believer on. And then we've got, I know, a small cadre of folks from the UK. And I did want to give a specific shout out to the Beaver Trust in the UK. I know you guys are having an event at some point tonight, although our time zones are weird, so maybe it's tomorrow or it's already happened. But the Beaver Trust is an amazing organization, and I will let folks look them up online. But just a shout out to Beaver Trust and the fact that myself, Kate Lundquist, and Emily Fairfax are actually all on the Independent Science Advisory Panel for the UK's Beaver Trust as well. So we're happy about that. You know, I think the interesting thing that we really want to bring forward is this recognition that beaver have been shaping landscapes in California for roughly 5 million years, if you really get into the fossil record. And throughout that time, and much more recently as well, we have several areas in Northern California in the Feather River Basin, and we'll hear about that probably from a few of our speakers, about carbon dated beaver wood, that we're talking about beavers that were making dams in high mountain meadows 1,200 years ago. And so beavers have been around a long time. They've been doing their work of slowing runoff and creating wetlands and sequestering carbon and building mountain meadows and flood plains and recharging groundwater and cooling stream flows, and especially for us in a Mediterranean climate, which much of California is, or the northern temperate rainforest areas, or these high mountain meadows, or the high and drier desert of the Great Basin on our eastern side. Beavers are these supremely adaptable organisms that have the capacity to really optimize these hydrologies and this associated ecology. And that's why we value working with beavers, especially this year in California. For those who aren't paying attention, we are going into what is absolutely historically one of the driest years we've had we're competing for the other records within the last 100 years, certainly the drought of the 70s. And so it's not that beaver make water, but boy, if you get water from the sky or you get melted water from the mountains, beavers certainly figure out how to keep it around, clean it, put it in the ground and help us buffer the loss of that or reutilization of that. Today, what's on our both days, both today, Wednesday, and then Friday at the same time, 1 to 5, then we'll have Q&A discussion afterwards. We've got 9 speakers lined up for you. And we're super excited, I know, as a collective, that and just all up front express gratitude to all of the speakers who've taken valuable time out of their lives to show up for us and share their experience, their wisdom, their perspective in the talks that we'll hear later today. But really, today, again, we're going to be talking a lot more about the idea of beaver essentials. And so we're going to get some clarification on the history of beavers in the state. We're going to get a little bit more clarification about the ecological contributions and, again, how they function in aquatic restoration, conservation. And we're going to end up talking a little bit about coexistence and how to successfully manage perceived conflicts with beavers. Beavers have big teeth, and they do things. They're famous for doing things, and beavers are fixing a lot of things that they didn't break, but they're here to fix them. Although sometimes some people may not recognize that needs fixing. So that will be an interesting one. And then on Friday, again, I'll talk more about that on Friday. But we've lined up another 9 speakers who are going to get more into a closer look from more biologists and watershed stewards and land managers about advances in beaver science and restoration, and talking about fire resilience and conservation of endangered species and cleaner water, and a little bit more on California-specific management and policy challenges and future directions. So amazing. We're just really looking forward to all of this with you all today. And so without further ado on that, I think what I want to do is just let you know, because I'm not going to really do bios for each speaker before they speak in the interest of time. You've all been to the website. That's how you registered. So we would reference you to go back to the website, and on that speaker page, there are photos and bios of every hearing and contact information, or the website or whatever they provided. So please avail your and there. But we're going to start off today with a wonderful keynote by Dr. Michael Pollack, who we're excited to hear from today. And I know Michael and I have been friends for quite a long time, and through the Salmonid Federation, when I was first able to cajole that organization into bringing Michael down, because so many of us have been so inspired by his work and others up in Oregon and Washington, recognizing the relationship of beavers benefiting salmonids. And so I just want to acknowledge that origin story there. Then hopefully my voice is not cutting out too much. Then we're going to hear from Ben Goldfarb, whose book hopefully you've all read, and if you haven't, run out and buy it right after we're done today. But Eager, the Secret and Surprising Lives of Beavers and Why They Matter. And then we're going to move over to Dr. Rickman and talk about shifting baseline syndromes. And then we're going to hear from Dr. Jeff Baldwin at Sonoma State about working with beavers and relationship of mitigating and adapting climate change. Hear from Trina Cunningham, the director of the Mighty Summit Consortium, on tribal partnerships and partnering with and then we're going to hear from Karen Pope.
Jeff, you got bumped up to being the host while we're dealing with our technical difficulties. It looks like you're on mute there.
Thank you. I can do that for a moment or two. Yeah, so our next speaker is going to be Michael Pollack. And so I'm just going to take a moment to introduce Michael. I am also an Oregonian, and that's where a lot of work that Michael's done has taken place. And I have visited the site where he's been doing work for so many years, one of the sites anyway. And one of the last great trips I did with my mother, actually, to Central Oregon, and she thoroughly enjoyed looking at the beaver works there. And throughout the last 20 years, as I've been involved with trying to get beaver back on the landscape, Michael has been sort of this central figure in helping people understand the importance of having beaver on the landscape. So feel very fortunate to have Michael join us today. I also have to say that of all the people I've met my entire life, Michael has one of the best hearts I have ever encountered. And I don't mean to overdo this, Michael, but thank you for being here, and thank you for doing everything you're doing, and thank you for sharing your wisdom with us today. So I'm going to turn it over to you.
Let's see if we can pull the technology off here. I'm going to see if I can share my slideshow. I may not be able to see any of you when I do that. Let's see. Okay, oh, I can see you. Okay, great. Can you all see this, this slide okay?
Looks
Looking
great, Michael.
great.
Okay. Hey, well, thank you. It's great to be here. I'm sure that my voice is going to modulate somewhere in here if it's like any other Zoom meeting I've been to. So I just want to acknowledge the organizers. I just really appreciate that you guys had the gumption to pull this off. I think it's great. And I think all of us understand that communication might be a little more challenging in the age of Zoom, but here we go. So beaver and salmon in the 21st century. And as you'll see, there's an asterisk there that whether we have beaver and salmon in the 22nd century is to be determined, as we will see later on in this slide. So, okay. Let me see, no, it's not advancing. Okay, all right, so just some quick overview of where beaver have existed. Worldwide distribution, they're a northern hemispheric species, Castor canadensis in North America. I think most of you know there was a pretty robust population, 60 to 40 million pre-European settlement. Now we're down to somewhere, probably actually more like about 20 million now. So the spatial distribution approaches its historic range. Castor fibers, the Eurasian beaver, it's really been whacked back. It was extirpated many centuries ago in much of Europe and Asia. But it's coming back too, and it's slowly expanding, and the value of it, they're a little behind us in terms of recognizing the importance of beaver as a conservation tool, but they are moving forward. I had an interesting trip in Mongolia a number of years back where they actually had introduced it to the arid parts of Mongolia, and that was a lot of fun. We didn't see a lot of beaver then. In fact, we didn't see any, but what we did here was a lot of enthusiasm for beaver in Mongolia, mostly on account of the quality of their fur, so and their value to the locals. So, but there are efforts going on around the world to restore beaver. Okay, again, I think most of you know that beaver is a habitat generalist and highly adaptable. The one thing it has in common, all the habitats have in common, is water. Very important ingredient, can't overstate that. But lakes, rivers, and streams, abandoned channels on floodplains and wetlands. Really wide ranging from boreal forests in the north and expanding northward at a rapid rate right now, particularly in Alaska. And then down to deserts, such as many that we find in California. So really quite a wide-ranging animal, quite abundant in the desert where there's water historically, less so now, but again, expanding. And then here's the distribution of Atlantic and Pacific salmon. It's mostly within the range of beaver, similar habitat usage in terms of the types of streams that they like. But as you can see, salmon are farther north than beaver and exist outside the tree line. But other than that, generally pretty much in the same range as beaver. And certainly they have been together in the vast majority of the range, the species or the taxa, the salmon taxa, and then beaver, the beaver genus. It's worth noting that they've had a long-term relationship, as Brock noted. The Castoridae and Salmonidae fossils first appear in the Miocene a little less than 30 million years ago. And keeping in mind the fossil record is very, it's pretty spotty. So this is just what we've seen. The modern castor and Oncorhynchus species really appear sort of about 3 to 7 million years ago. And then we see beaver ponds in the fossil record appearing in the Pliocene about 3 to 5 million years ago. And these shots are just to show you that when we're talking about beaver, and historically there's been a number of different types of beaver, and we're talking about salmon, there's been a number of different types of salmon that have existed over the millions of years. What's interesting is that with genetic studies, DNA studies, it found that castor fiber and Castor canadensis diverged about 7.5 million years ago, and that both are dam builders. So that's led some to conclude, you know, certainly with reason, that the dam building behavior in beaver probably has existed for at least that long. That is, that they both species diverge from a common ancestor that built dams. So an indication that regardless that beaver and salmon and beaver dams in particular and salmon have been existing on the landscape for millions of generations. So they've had had some time to work through the bumps and challenges of a relationship for quite some time. And in particular, it's worth mentioning because beaver dams are something that seem to be an ongoing controversy in terms of whether they are problematic for salmon or not. So it's important to remember that they've been in relationship with each other for quite some time, have done quite well. It's also worth mentioning that given that there's quite a contrast in terms of relative to humans, that beaver have a lot more dam building experience. And you know, we've got about 5,000 years of dam building experience as human versus about 5 million, give or take, of beaver. And then there's some fundamental differences in the types of dams that are built. And you can just pause for a moment here and you can look at the two, the comparison between a human dam and a beaver dam, and maybe jot down some of the differences that you see in there. Some of them fairly obvious. One of the key ones I think you can see is in terms of upstream and downstream movement. You can see the human dams going to provide some challenges that are not as inherent in the beaver dam. You also notice the vegetation around the edges. That's a common theme of beaver dams, is that they're well vegetated, whereas a lot of human dams, the reservoir upstream is not necessarily well vegetated because it fluctuates. And then the depth is different. There's a lot more depth relative to the surface area of the upstream pond of a beaver dam that's suitable for colonization by vegetation. And so that has a lot of implications in terms of terrestrial production or primary production and suitability for fish habitat or salmon habitat. There's a number of others. Obviously, the width and depth are quite a bit different. The overall scale is quite a bit different. And should a fish go over the top of a beaver dam, it's likely to survive. Whereas if it did go over the top of that dam, should it have managed to get upstream, survival is a little less certain. So, and then canal building, that's another one. Beaver kind of beat us pretty well in terms of canal building experience. And I would say, in a nod to recent events, canal navigation too. Beaver seem to have a little more experience in that regard. So there's some fundamental differences here. Again, the vegetation on many of our canals is lacking, and that causes problems. The depth, the accessibility by wildlife. There's also things that you can't see here, which is fluctuations in water levels. That's problematic too. The substrate on the bottom is often very different. So it's worth mentioning because we build many of the structures that Beaver build, but they have a different approach, and that approach has been a much more sustainable approach. So there's much to learn from them, both in terms of construction and navigation. And then stream restoration experience, they really have us beat there. So they've been restoring and managing streams for some, again, 5 million years. And I'll give humans 100 that we've been really seriously at it. And note there's some fundamental differences here in their approach to stream restoration and management. You can really see here they've raised the water table. The Beaver have raised the water table, put numerous structures into the stream system, dams primarily, and they've really raised the water table and expanded it. I mean, look at this huge area that is saturated in this example of a beaver dam, a beaver management stream managed by Beaver. And then if you go over to the right, where you've got engineers here, they're managing a stream like this, and there's some fundamental differences here. Here the emphasis is really on stability and connectivity. So there's root wrap there to kind of create a natural look, but that doesn't allow the stream to move. So there's not a lot of dynamism to it. There will be eventually vegetation there, but it's at the moment it's much less vegetated. Note also the water table is much lower most of the time. So we've really created kind of an incision trench, a meandering incision trench. And this is, it's a common restoration approach these days, although we are evolving. Some fundamental differences, and the primary one really to take home here is that the water table is managed at a different level, and Beaver really manage the water table so that it's at or above the water, or excuse me, the elevation of the ground, whereas we tend to manage our streams, even when we restore them, such that the elevation of the water is below ground level or below floodplain level for most of the time, just rising up to the top occasionally. And then this is really a key slide here that millions of years of stream management experience is really important. The Oncorhynchus and Salmo and as a whole had been around for first, like I said, identified tens of millions of years ago, and in that time, this fluctuating line is change in temperature degrees Celsius relative to sort of the historic, recent historic mean. And what you can see is that Castor and Oncorhynchus, or Salmidae and Castoridae in North America anyway, have been through a lot of climate change. They've really dealt with a really fluctuating climate. Beaver ponds, beaver dams, they've been dealing with a very fluctuating climate from the mid-Pliocene through the last interglacial, and then on to the mid-Holocene. Now, if you look at where we have been in terms of our dam and canal building experience, we're really in a very narrow, even if you go back to 5,000 years, we're in a very, very stable climatic experience. So we have developed our technologies in a very stable period in the Earth's history, in recent Earth's history. What's also worth noting is if you go to the right, the projected increases in temperature in the next century or two are actually outside of the range of the conditions under which both Salmonidae and Castoridae evolved. So we will be entering a new climatic regime. And that's not to say that they can't exist. It's just that in this new climate, it's just that they haven't. But it also speaks to the fact that if we're serious about restoration and in the long term and thinking beyond 50 years, but really thinking about the next couple of centuries, no restoration is probably going to be very effective unless we actually address the global climate change issue, the emission of greenhouse gases. That's really kind of the #1 restoration priority right now. But it's just also to keep in mind, though, that we have had a lot of fluctuations in the past and have survived them, just none quite as severe as what's projected. So species can handle and evolve under some really variable climates, but we're kind of going outside that natural range of variability. So we'll see what happens next. See if there's anything else. Okay, and this is just another one. This is from the West Without Water book. Just that we've also seen salmon and beaver persisting through major sea level changes. Well, I mean, you look at the amount the sea has bounced up and down in the past 5 million years or so, and 500,000 years, excuse me. Quite significant. So there's been a lot, and you imagine us and as a society dealing with these kinds of fluctuations, and you can imagine the challenges in terms of the infrastructure movement that would be needed to address sea level changes of a couple hundred feet. So again, some adaptability challenges with our approach to water and stream management that we might do well to look at how beaver have been approaching it. Another thing, so moving on a little bit, another thing to keep in mind is that there's a tremendous overlap between beaver, salmon, and people habitat. And this is a map, a beaver intrinsic potential map from the Snohomish River Basin in Washington. And you can read more about this in Dick Brenner and all's 2018 paper in PLOS One. But what you see is the land use types 1, 2, and 3, which are really residential, urban, and then agriculture, 1, 2, 3. That the red in the intrinsic potential is this high valuable habitat. And so what you can see is the red lines showing stream segments that are ideal for beaver really overlap with the heaviest usage by people. And then I don't have it shown here, but those low gradient systems are really the areas where we find most of the salmon habitat as well. And then the green is steeper forest land. And you can kind of get a sense of that over on the right-hand side. Over to the right is the headwaters, high mountain. You see snow-capped mountains, pretty steep terrain. And then you see the Snohomish River to the south, and then the Skykomish to the north. And then here is the port of this nearby Everett, and really a lot of colonization of the low-lying areas by people, colonization for farmland. No big surprise there. And then this is the burgeoning city of Seattle, soon to be changed to Amazonia, potentially, the name change. We'll see. And then up in the upper right, you can kind of see a little more clearly without the intrinsic potential map there. But so a lot of overlap, which creates some problems. This is just kind of another take of that again from that same paper, showing that the preferred habitat of beaver is really fairly kind of medium-sized valley with small streams and low gradient streams. That's really what these show in here, and really fairly tightly clustered. So they do have a fairly preferred habitat and pretty easy. And they don't like steep slopes. They don't like, in terms of dam building, don't use big streams for obvious reasons. And so our approach to the competition is our time-honored approach is to get rid of things that compete with us. And so we wiped out the beaver mostly, but not entirely. And of course, this played out over, as I mentioned, centuries, really millennia in Europe. Same thing, but we kind of cleaned them out pretty quickly because, well, their fur was valuable, but they also were right in the way of areas that we wanted to settle. So now I want to move to something that we are better at beaver. The one thing is we're really good at drainage. So our engineers are really good at draining things. We have about 5,000 years of experience there, and beaver really don't have any experience. They're not very good at draining. They kind of are a Johnny one note, you know, they flood things. So we got them beat there. And these are some examples of drainage just to give you a sense of the scale of it. This is to the left is the Delta region of the San Francisco Bay Area. And there you can just see the intensity of the drainage network to lower groundwater so that we can grow crops. Here's the schematic here, just shows kind of the tiling, pretty this has gone on all over this country and other countries globally, but putting in drainage tiles and then draining down the land, creating swamps, arable lands out of swamps. The image on the bottom is just showing the drainage network, how the tiling, how dense it is. And then here's beaver on the right that don't know how to do any of this. So, because it hasn't served an ecological advantage to them. So that's the short of it. And then really globally, this drainage, and I include incision, it has significantly affected the hydrologic cycle. And I say this, because when you add it up, it's really quite shocking. And if you look at these parameters, the total area of arable lands, that's just cropland in use right now, is about 1.5 billion hectares. I converted everything to cubic meters or square meters. And if you drop down the water table 1 meter, you drain globally, it drains about 4.5 times 10 to the 12 cubic meters of water. That's about 4 trillion, 4.5 trillion. And that's roughly equal, a little in excess of our annual global freshwater consumption. So a fairly significant amount. If you look at the other interesting figures, if you look at the global land precipitation, in particular the amount of land precipitation that's not evaporated, it's actually a fairly significant amount of it, about 10% or 12%. It's around there. What we're at 12% of is the actual global freshwater discharge. So you look at how many, it's about 37,000 cubic kilometers of freshwater discharge. The amount, assuming a rather conservative estimate that we've drained are on average our arable lands by 1 meter, that's 12% of the global discharge. If you think a more probably reasonable number, maybe a little bit high, but 3 meters of drainage on arable lands, not unreasonable really. That's 36% of our global discharge, annual discharge. And then keeping in mind that arable lands are about 12% of the global land surface, and that other land use activities, such as grazing or forestry, also cause incision and subsequently lowering of the water tables. So tremendous downcutting and tremendous loss of water storage potential in our systems. And I think many of you in California know that there's parts of the Central Valley, the Sacramento Valley, that have drained much more than that. Groundwater withdrawals and such have really lowered water tables significantly. So it's a big problem. I don't think anyone's actually really figured out the extent of it. But especially now with climate change and such, we're really having to start to take a hard look at that and see we need to look at that. And really, I see a very key role for Beaver in all of this because of what they do in terms of raising water tables, in terms of their natural intrinsic behavior, they want to recharge this groundwater and bring that water level up to the surface. So kind of wrapping it up here, and I'm sorry for the little bit of blurage on these images, but the internet is what it is. Just to keep in mind that you know, these large-scale problems, climate change, loss of water storage, they require large-scale solutions. And you know, if we're really talking about beaver restoration on any serious level, we need to do it at a watershed scale. To the right, I just put this out there. You know, to the right is shots of the Loess Plateau in China, and they embarked on this major restoration project. An area the size of Belgium was getting blown away, literally, in Loess is wind deposited soils, and it was blown right away because over centuries they had stripped the vegetation off, and so they had essentially created an arid environment, a very arid environment, and a formerly lush, what was formerly a lush environment. So they just went to work. They used mostly hand labor, and they did terracing, and they just did so much work planting. And they've, in a very short time, I mean, just a geological blink of an eye, they have created these very lush oasis and created productive farmland and such in these areas that had very little economic or ecological value just a few decades ago. So it's really something to behold, to see that it can be done. But to do that for us, we need to really cut what's been called the green tape. And we have a lot of environmental regulations that have been put in place to protect what's there, to prevent further degradation. But it's a bit, in my view, like shutting the barn door after the horses escape, that we can't just simply protect what's there. We actually have to engage in restoration. And we're finding that many of the rules designed to protect the land is now preventing us from restoring it, because it's a lengthy and costly process. And it really gets in the way of people moving forward at the scale that the restoration needs to occur. And it's hard for me to get my arms around the permitting process to do something like what China did. And at the same time, there's other countries, I mean, including Ethiopia, Jordan, Egypt, and again, China, that are engaging in these massive large-scale restoration projects. There's a project, the Greening of Sinai, where a Dutch firm is working on it, the Weather Changers. They're actually looking at making the Sinai green again, and that was an area that had a tremendous civilization history in it. And what they're finding, and with some of the more advanced modeling now, is that you actually can change the weather with increased rainfall, because you simply get more evapotranspiration when you have vegetation. So, and then that allows for the saturation of the atmosphere sufficient to cause rain. So, truly inspirational work, and I really want to leave with that sense that the scale of what we need to do in terms of restoration, in terms of habitat management, is massive and daunting, but it is doable, it is being done. And that really the U.S. is falling behind. Like many things, we're really falling behind in the restoration field. So take-home messages. Well, the obvious one, but it can't be said enough, is that fish and beaver need water. It sounds trivial, but that's actually something that we really need to remember as we move into a changing climate in California in particular. The primary difference between beaver and people in terms of salmon habitat management is that beaver tend to raise water tables and people tend to lower water tables. Another key thing is that beaver have managed salmon habitat for millions of generations with positive results. Beaver people, excuse me, have been managing salmon habitat for dozens of generations, just dozens, and our results have been less positive. A lot of extirpation of salmon populations in particular. In my view, green tape is likely the biggest impediment to meaningful salmon habitat restoration. We really need to work on that. We need to kind of loosen up the regulatory constraints if we're going to tackle this at a meaningful scale. Restoration is at an unprecedented scale is going to be required. We're not going to get where we need to go by dinking around the edges. So. And then recommendation, pardon for the bad pun, life is short, start with deserts first. And that's really, the reason I say that is because that is really where you can make the most impact. Focusing on restoring habitat in areas where the benefits are most obvious, I think is really important. And frankly, we're seeing desertification around the world. And it's, in terms of sustainability on the planet, dealing with desertification is really, really going to be key. We need functional ecosystems everywhere. It's not just a question of sort of productive ecosystems or ecosystems that give us some economic benefit. We need to actually have functional ecosystems that store carbon and that create a climate that is something that we want to live in. So. Lots of room there, and there's also a lot less to lose there. So perhaps from a regulatory perspective, it might be easier to move forward. So just leave you with this little footnote. Many mass extinctions have been caused by a massive release of carbon dioxide into the atmosphere. That's really been the primary cause of extinction. We're doing a lot of modeling these days, and I'd say that the global climate experiment we are performing has been done before. There are examples of what happens when we release the amount of CO2 into the atmosphere. The results were not good. In some cases, the biodiversity of the Earth was really, really low for millions of years. So we don't really need models to tell us what will happen. We got a pretty good idea. I'll just leave you with this because ultimately we're talking about Beaver and how we're going to manage Beaver and Beaver as a restoration tool. It's all well and good, but the real key restoration tool is going to be finding an alternative to producing greenhouse gas emissions at the scale that we're doing. So none of this is going to matter if we don't really tackle that and really get on it. So with that, I will, I guess, entertain questions.
All right. Thank you, Michael. Woohoo! So fun. I love your contrast and compare between the bipedal saxo-saline solution and the furry orange-toothed quadrupeds. You made your case well. I'm on board, and my furry friends will concur that I think you've done a good job. My take is just pondering. I'm looking at the questions, and thank you, Jackie, for grabbing them. A number of the questions that have to do with beavers navigating dams relative to upstream diversions. Is trapping and relocating beavers legal? Is questions around beavers and benefits overall for salmonid species. I do have a sense that I know other speakers coming up are also going to be dropping into a bunch of this content too. And I feel like the high level of some of those questions is such that relative to the time we're at right now, I just want those questioners to keep paying attention to the upcoming speakers because I think we're going to catch a lot of that there. And as far as the whole types of green, there's someone asked a question about types of green tape for California. I don't know if Michael's aware of this, but there is a cutting green tape in a process that is happening right now at the state level in California. And people, I will just reference the audience that if you're interested in that, put those words in your search engine and look that up. And it's about restoration and yeah, it has to deal with CEQA and a whole bunch of stuff. So I'm not sure we want to go there. So my take is based on all of that, unless you got one punchy little takeaway that you just need to leave us with, Michael, I'll give you a sec for that. And then we'll transition over to Mr. Goldfarb here.
Not really. I think I guess I would just leave with the green tape, which is that really my experience working and doing restoration in California is you gotta cut through that. You just have to figure out a way. So I haven't not looked in details at the initiative, but I just feel like there's so many intelligent, creative people in California. It just feels like this tremendous, tremendous intellectual and sort of moral energy that wants to focus on restoring and keeping this planet sustainable. And it just kills me to see the bureaucracy getting in the way. It's like, well, you know, we would have saved the world, but you didn't fill out form A223Q in a timely fashion. So it's just, we got to get past that. We got so much to do, and we got to get out of our way. We've got to get out of our way. It's really, it's more than just a good idea. It's really becoming a moral imperative, a survival imperative. So that's where I'll leave you with.
Great.
It's really up to us if we want to survive.
All right. Thanks, Michael. Well, we'll just keep in mind that when people invoke the idea of streamlining permits, let's just invoke the idea that we should stop lining streams from the beginning and actually just unline streams. So streamline permits, but not actual streams. Okie dokie. I'm going to switch us right on over to Mr. Ben Goldfarb here, and he's going to talk to us. And thank you so much for being here, Ben, and take it away.
Yeah, thank you so much, Brock, and thanks to all the event organizers for letting a humble journalist be part of this august panel of scientists. And, you know, really, I mean, so many people in the California beaver world, Brock, Kate, Heidi, Rick, Michael, Sharna, Emily Fairfax recently have been so helpful to me as a writer. I just want to say thank you so much for letting me be part of the caster community over the last few years, and for letting me be part of this this panel. So other speakers over the next couple of days are going to talk about the ecological, hydrological, geomorphological benefits of beavers in great length. But I just wanted to talk a little bit today about sort of the history of beaver-human relationships and how those relationships have shaped landscapes in ways that we're just now beginning to understand in a fresh way. And, you know, I think that the first thing to emphasize, and Michael touched on this in his great talk, but I just wanted to sort of dig in a little bit deeper, is just how extraordinarily ubiquitous and abundant these animals were prior to European arrival, how dramatically they shaped North American landforms. Again, as Michael said, you know, pre-European populations were as many as 400 million. This is just an unbelievably abundant common species. And of course, hundreds of millions of beavers would have created hundreds of millions of beaver ponds and wetlands. You know, perhaps 250 million or so is sort of the best guess that we have. And all of those ponds and wetlands, you know, a little sort of back of the envelope math suggests might have impounded something like 230,000 square miles collectively, which for reference is about the combined extent of Nevada and Arizona. So just a huge amount of this continent was influenced and impounded by beavers. And as Michael said again, you know, this was also a remarkably ancient species. You know, the dam building behavior goes back at least 8 million years, and probably a lot longer than that. And as a result, you know, I mean, hundreds, if not thousands of species in North America are intimately co-evolved and adapted to the kinds of landscapes that beavers create. You know, Michael, of course, talked about salmon at great length, but, you know, you can hardly name a species that's not dependent on beavers, or at least doesn't benefit from their presence in some way. You know, passerines, songbirds perch and nest and feed in the kind of coppicing willow that beavers create. Waterfowl, of course, are very closely associated with beavers. You know, aquatic mammals like mink and otters and muskrats. And then amphibians. I know that other speakers will be talking about the role of beavers in creating amphibian habitat. But here's a boreal toad, a species that in much of its range is essentially a beaver pond obligate and is lost without beavers. So this is a species that's just extraordinarily deeply embedded in North American ecologies and supports a lot of ecological weight. Beavers are also deeply embedded in human history as well. We're talking about partnering with beavers, using beavers to create these sorts of ecological oases. But that's a relationship that indigenous people have understood for thousands of years. Rosalind Lapierre, the Blackfeet historian and botanist, has written beautifully about how Native American tribes on the Great Plains, like the Blackfeet, sanctified beavers, considered beavers a kind of a sacred species, and refused to kill them because they understood that in the arid American West, water meant life. And that's the reason that when the industrial fur trade reached the American West, guys like Jim Bridger and Kit Carson and Hugh Glass had to go trap beavers because, unlike on the East Coast, Native people wouldn't do their dirty work for them, wouldn't participate in the fur trade because they had this incredibly sophisticated ecological knowledge about the role that beavers played on the landscape. So I think that's just an important thing to emphasize, of course, is that nothing that we're talking about today is original to Western science. So when European traders, trappers, explorers, railroad surveyors did arrive in the American West, they were just universally gobsmacked by the depth and breadth of the beaver influence they encountered, and trappers' diaries and explorers' journals are full of this sort of observation. But Lewis, of course, of Lewis and Clark fame, describes seeing beaver dams in every single tributary of the Missouri Basin in Montana, as far as the eye could see, up into the mountains. And in some places, in fact, the Corps of Discovery couldn't even use those valley bottoms. They had to, walk along the ridge lines because beavers had so thoroughly ponded everything up. So, this was, I'm always, I wish I could have been there to sort of witness a fully castorified American West. It seems like quite the spectacular blue, wet, green, lush place. So that was in 1805 that Lewis and Clark saw beaver dams in every single tributary. In 1843, John James Audubon, of course, the naturalist and painter, traveled the exact same route up the Missouri River, looking for a beaver to paint, and he couldn't find a single beaver in an entire watershed where Lewis and Clark had seen them ubiquitous just 4 decades earlier. So what happened to beavers? Well, of course, they became hats. Michael alluded to this in his presentation, but the industrial fur trade kind of begins in the early 1600s in New England and spreads very rapidly west and south across the continent, trapping beavers out of every river, lake, stream, and pond that traders and trappers encountered. I know that Rick, I'm sure, is going to touch much more upon the sort of the specific fur trade context in California, but kind of the general sort of continental contours of it are, by the 1840s or so, beavers are nearly functionally extinct. Certainly in the lower 48, the nadir of the population was maybe 100,000 or so, nearly all of them in Canada. And it's really hard to overemphasize the extent to which this industrial fur trade drove early American history. Practically every significant historical event prior to the Civil War has some kind of deep beaver connection. The Revolutionary War, one of the offenses that sort of angered the colonists enough to revolt against the British was the British denying them access to trapping grounds west of the Appalachian Mountains. The Louisiana Purchase that was fueled largely by Jefferson's desire to secure new trapping grounds. Of course, the smallpox that was spread by white trappers and traders was sort of spread in the course of the beaver trade in many cases. Just one indication of how deeply ingrained this resource was, this commodity was, is this beaver coin. So this is, I live in Washington State, so we're part of the former Oregon Territory. So in 1849, the Oregon Territory minted a beaver coin, which was fixed to the value of a beaver pelt. So the entire economy, the entire currency operated on the pelt standard. That's just an amazing indication, I think, of how integral these animals were in sort of early American economies and life. So in addition to being a hugely consequential historical event, the fur trade was a really dramatic ecological event, right? We don't think about fur trapping in the same terms as, gold mining in the Sierra Nevada, or the damming of the Columbia River, or the deforestation of New England as one of the kind of the seminal ecological disasters that shaped North America. But there's no question that it was. I mean, what happens when you trap out several 100 million beavers? Well, hundreds of millions of beaver dams break down, and you lose those ponds and wetlands. In some places on the eastern seaboard, when those beavers were eliminated, so much nutrients and organic matter flowed out of those beaver ponds that it actually fertilized an enormous plankton bloom that settled out. And today, if you take a sediment core in the Long Island Sound, you can see the signature of diatoms that were fertilized by all of those busted beaver ponds. So that's a kind of an amazing indication, I think, of just what a dramatic geological event the loss of beavers was. And of course, beavers, the loss of beavers changed our aquatic systems in unbelievably profound ways. Of course, in a healthy beaver-rich stream, all of those beaver dams are acting as speed bumps, slowing water down and spreading it out laterally onto the floodplain. And when you lose those beaver speed bumps, there's nothing checking the velocity of water, and you often get really dramatic erosion and incision and this sort of floodplain stream disconnection. And I think that oftentimes we see this sort of image of a stream that looks like this one, and we associate that with overgrazing or mining or some other historic impact. But in many cases, that's the result of the loss of beavers. This is a stream in Wyoming where exactly that dynamic happened. And of course, that floodplain stream hydrological disconnection was a profound catastrophe for all kinds of creatures. Michael talked at great length about salmon, so I won't belabor this point. But on the Olympic Peninsula in Washington, for example, the loss of beaver ponds and other features contributed to about a 97% loss of winter coho rearing habitat. So again, I think that's if you take nothing else from this short talk, it's that the loss of beavers is a profound environmental disaster for all kinds of creatures. So fortunately, by 1900 or so, we begin to wise up a little bit. Various states have beaver reintroduction programs. Oregon, Washington, Utah, California actually parachute some beavers in, which maybe Brock and Kay will talk about later. And these animals begin to recover. Of course, as beavers recover, they find themselves reoccupying habitat that we have colonized in their absence. Michael beautifully pointed out that good beaver habitat and good human habitat is kind of one and the same. So in the 20th century, there's really this shift in our relationship, right, from commodification to conflict as we increasingly clash with these animals that are moving back into the landscapes that we've colonized without them. I like this picture. Here's a little cabin that I ran into in New Mexico. And what you can sort of see in this picture is that the beavers begin their dam up in the top left corner of the screen, dam up to the base of the house, then incorporate the house in their dam, and then carry on the other side. So, I wouldn't want to be that landowner, but you have to sort of admire the ingenuity there. Of course, the way that these sorts of beaver conflicts are generally handled is by trapping out the offending beaver. Again, I won't get sort of too deep into the history of beaver management because I'm sure that Kevin's going to talk a lot about sort of coexistence strategies. But suffice to say that every year the federal government, the Department of Agriculture, kills about 20,000 beavers in North America, and private, quote unquote, nuisance trappers take certainly tens, if not hundreds of thousands more. We don't really know, but there's a whole lot of beaver killing going on. I think that you know, that sort of, I mean, you know, we have to learn to embrace more creative ways of living this animal. You know, again, I'm sure that Kevin's going to talk in great depth about this. But you know, here's a really nice case study that I liked bumping into in Colorado, where a local land trust, you know, had these beautiful old cottonwood trees they wanted to protect. So they fenced off the native cottonwoods. And then left unfenced the non-native Siberian elm trees and let the beavers fell those. So that's sort of invasive vegetation management using a beaver as your agent. I think that's pretty cool. So, you know, if we're going to sort of change the polarity of our relationship with beavers, we have to learn to embrace that sort of creative conflict resolution and coexistence. You know, again, I think that we're really entering the third phase of beaver human relational history. The first, again, was sort of commodification, perceiving these animals strictly as a resource. The second phase was sort of conflict and our knee-jerk lethal approach to managing these animals. And the third phase has to be collaboration through the use of coexistence techniques like flow devices and fencing and beaver dam analogs, which I'm sure that Sharna and that the Scott Valley folks will talk about in great depth. But I think that living with beavers doesn't just entail or require using technologies like beaver dam analogs and flow devices. It also entails a reconfiguration of our historical imagination, right? When we trapped out beavers, we changed the landscape in ways that we're just now beginning to recognize, but we internalized a profoundly inaccurate idea of ecological health, right? You know, we sort of learned to think of healthy streams as these free-flowing, fast-moving, cobble-bottom, single-thread, you know, sort of sine waves just shooting through the landscape. When in reality, you know, we know that in many cases and places, these beaver-created habitats were much more rule than exception. That, you know, that a healthy aquatic system is a marsh or a swamp or another wetland type, where the water is, you know, is moving slowly or not at all. There are channels going all over the floodplain. There are dead and dying trees everywhere. It smells kind of funky. The ground is mucky when you walk on it. You know, this isn't the sort of landscape that you would see in a fly fishing catalog. But again, you know, we know that these sorts of beaver-influenced landscapes are profoundly healthy and beneficial in all kinds of ways that other speakers will talk about. So I think that's the kind of the challenge that I want to leave you with is, you know, how can we dispel our kind of ecological amnesia and think about these landscapes in a more holistic way. And you know, just the final point, the point that Kent Woodruff from the Methow Beaver Project up in Washington, who was sort of the person who got me excited about beavers originally, you know, the point that he made is that we are not smart enough to know what a fully functional ecosystem looks like, right? We especially white people like the guy talking, you know, weren't here thousands of years ago. We haven't experienced a fully beaver occupied landscape. We don't really know what we're restoring our ecosystems to necessarily. But beavers, of course, will do this work instinctively. They'll do it for free, and they'll do it with a whole lot less of that green tape that Michael mentioned. So with that, I don't know if we have time for any questions, but yeah, thank you all so much again for letting me be part of this conversation, and I'm really looking forward to the other speakers to come.
Woohoo! Thanks, Ben. Love that. My take is in us just cruising along, and again, I think some of these, it's interesting, the folks are asking the questions, and you're almost kind of priming the pump for the next speaker, and we've kind of lined it up. It's like we're staging your question. And so I think some of the stuff around genetic bottlenecks, I believe Rick might address a little bit, because he's going to drill into the California case, which if there is a bottleneck example, California certainly went there. And as far as thinking about beavers in urban watersheds and ecological restoration, again, and the relationship of beavers and ecological restoration, those are going to be the topics of other talks to come. So I think with that, Ben, we're going to keep on rolling, and thank you for that. And then we'll be able to have Q&A with everybody at the very end. So thank you for that. And I'm just going to turn it right over to Dr. Rick Landman here, who's going to talk to us about shifting baseline syndrome and the rediscovery of beaver nativity in the coast of California. Hi, Rick. Nice to see you. Nice elk.
Hey,
Take it
can you
away.
hear me okay? Yes,
Yep.
great. I need to get rid of all my speaker photos. Here we go. Thanks, everybody. It's an honor to be here. I'm sort of mostly retired, physician, and most of my career was cancer genetics with side trips into several other medical specialties. I'm widely published now in medicine, but I'm a novice in ecology and publishing, but my fourth paper was just accepted and will extend the range of Chinook salmon on our coast about 120 miles further south, which should be out in PLOS One shortly. In my retirement, I just launched this Institute for Historical Ecology. It started with work in Beaver, but from the logo, you can get an idea of some of the California fauna that I think we could, with historical ecology, better understanding where they were, hopefully guide restoration in the present. I want to acknowledge the many, many people have helped us with our research in the 3 publications we're going to talk about today, beginning with the indigenous peoples, who had, of course, words for beaver from the northern border of California to the southern border and east to west, and archaeologists, ethnolinguists, historians, museum curators, and of course, my co-authors, beginning with Heidi Perriman, who, and Brock Dolan, who I think were the first beaver believers I met before I came out as a beaver believer. Was a little nervous about it, but many others, so thanks. Shifting baseline syndrome, of course, Daniel Pauly's idea in 1995 that biologists tend to think of a fishery stock as the population numbers probably were always historically what they were when I was young or when I started my career. And they measure changes in the population of that species. He's talking mostly about fish, but it's going to apply equally to beaver, wolves, swans, goes on and on. They evaluate changes against what they knew. And then if you challenge these assumptions, people don't like it. People, as Thomas Paine said, a long habit of not thinking a thing wrong gives it a superficial appearance of being right and may raise a formidable outcry in defense of the customary thinking. So we wanted to blow away conventional thinking. And what got me started was I live on a creek, Adobe Creek, which is the border between Palo Alto and Los Altos, California. And the man I bought my house from in the 1980s, who was 80 years old, he said, you know, I used to fly fish in this creek year round, and now it's dry 8 months of the year. And one of my hypotheses was maybe it went dry because there were beaver here. And beaver ponds perennialized the stream by raising the water tables. Of course, conventional logic was that's impossible. There were never beaver here. There's no museum records of beaver. There's not even archaeological. And this led to a series of papers. First, this novel physical evidence of beaver in the Sierras, where they were thought not to ever live. And then because that was just one creek and one piece of evidence, I and others here expanded our review to get a more comprehensive look at the evidence for beaver in the Sierras, and then the whole coast of California in the third paper, which ever-expanding list of co-authors. So these early naturalists, Frank Stevens in his 1906 book and Harold Bryant, they talked about beaver as being native to all of California, just having died out or been extirpated down to a few survivors in the Central Valley. Why would they survive in the Central Valley? Because the way you take beaver in the fur trade is you tear a hole in their dam and put a trap there. When they go out to repair the dam, they get caught in the trap. But in the deep waters of the Sacramento and San Joaquin and the Delta Tule marshes, the water's deep enough they don't have to build dams. So they're really hard to trap. They've under the surface bank burrows, and so very hard to catch. So they survive there. Joseph Grinnell, the first director of Berkeley's Museum of Vertebrate Zoology, kind of changed the thinking, sort of very much in line with this shifting baseline syndrome that, you know, they weren't really anywhere in the Sierras before, at least not above 1,000 feet, and they weren't in any coastal watersheds, except maybe the Klamath and up in the northeast corner of the state, up in the Pitt River watershed. And this book, published in 1937, carried a lot of credence because he was, after all, the director of the MVZ. There wasn't really a method section in this book, but he talked to trappers and he looked at specimen collections in his museum. It's an interesting map now of his, which you see beaver specimens and historic observer records, mostly from trappers in the Central Valley, up in the pit. He puts a question mark by this one at the mouth of the Klamath, the specimen he has in Berkeley's Museum of Vertebrate Zoology, and another question mark by this one from Sespe Creek in Ventura County, where it reaches the Santa Clara River, another beaver skull he had. He discounted those. He questioned their veracity. It just didn't fit into his thinking that they only lived in the Central Valley, even though they lived in the deserts of northern Mexico, all the way up, as Michael Pollock said, up to the tundra boreal forest border in the north. Something about California in the Sierras and the coast and SoCal was just too fiendish for beaver to survive, I guess. Donald Tappy, a few years later, 5 years later, in 1942, publishes the status of beavers in California Game Bulletin. He expands the range a little bit. You see, he's now giving him this Klamath mouth as part of their historic range, and the Colorado River, of course, which is desert, is part of historic beaver range in the Central Valley. Some of these other dots are translocated beavers because CDFG, now CDFW, of course, did beaver translocations all over the state. Most of them have been successful, but he still excludes most of the coast and SoCal and the Sierras. Heidi Perriman introduced me to an archaeologist, Charles Darwin James, who was working on Red Clover Creek in the Feather River watershed. This site is about 60 miles north of Truckee, about over 5,000 feet elevation. So far above Grinnell's limit of 1,000 feet up in the Sierras was their limit. And of course, all these montane meadows had these incised streams in them. They were doing pond and plug repairs and asking archaeologists to come look over these sites. And James finds these buried beaver dams, interlaced sticks, angular cuts on the tips of the sticks, and he radiocarbon dated them. And we wrote this up. The sticks at the top of the dam dated to 1850 with radiocarbon dating, the middle 1730, and the bottom 580. So this is actually a series of dams, all in the same location, which I understand beaver do. They tend to rebuild in the same location over a millennium. This is the first physical evidence of beaver. Because beaver are aquatic, their remains wash away. So you had to go outside, think outside the box really to find physical evidence of beaver using this novel approach. But people challenged us. They said, well, that was just one spot in the Sierras and one type of evidence, and maybe that was the only place they were. So Heidi, Eli, Sarah, and Brock Dolman, and Michael Pollock, Kate Lundquist, we looked further in the Sierras and then in the coast, and we ranked the evidence. So physical evidence would be like a museum specimen, the radiocarbon dated beaver sticks, archaeological specimens. We're looking really, we wanted historic European contact, or maybe back a little further, maybe just late Holocene, 2,500 years before present, or 500 years BCE to the present. The second level of evidence was historical accounts, but credible observers, like scientists, even trappers, who actually can be highly credible. And they can tell otter from beaver, rangers and early naturalists. And then a lower level of evidence, which we call supplementary evidence, was the habitat suitable? Well, that question is already pretty well answered because beaver have persisted for now, we're getting up to 100 years almost. All these translocations by CDFG 80, 90, 100 years ago, and they're surviving in most of these watersheds. The ethnographic data, geographic place names. Was there a stream named Beaver or a place named after Castor? And historical newspaper accounts. So three levels of evidence. And we said, let's put it all together. So if you challenge one piece of evidence, maybe we can get a big enough aggregate of evidence that the story will become overwhelmingly convincing. First, let's look at archaeological sites. This is using Fawn Map, one of these internet sites where they try to let you look up all of the archaeological specimens by species. And you only see 2 dots because back in 2013, one up on the Pitt River and one here in the Central Valley. You don't see beaver on the coast. You don't see them in SoCal. You don't really see them in the Sierras if you look for archaeological specimens. Now, we know this wasn't true because if you dig in the literature, the Emeryville Shell Mound has lots of beaver remains in it. It also has lots of sea otter. But here's the same fawn map look for sea otter. You see them way up in NorCal. You see them down below Point Conception. You don't see them in the Big Sur at all, the sea otter. And you see them in Oregon. Well, they're not. Of course, we know the remnant population was in the Big Sur. So it's not just that aquatic species are challenging when you try to find specimens because they get washed away. It's also that these archaeological databases are very incomplete. The same thing is true for museum records, and we'll come to that. But the point I want to make is you actually need to get into the primary literature. You can't just trust these databases. And of course, emphasize that lack of evidence doesn't prove that a species was not present. In fact, in the literature, we did find archaeological remains in the Emeryville Shell Mound, as I mentioned, and a beaver tooth in the Alameda Creek watershed, and then a beaver molar now on the coast in Humboldt County. Then we go from archaeological to museum records. The challenge in California, and I think of any state, we probably have the worst understanding of what our fauna was in California historically, because our museums are so recent, right? This is really just a Spanish and briefly Mexican colony. The US takes it from the Mexicans in 1848. Some museums get started before 1900, but the California Academy of Science, their whole collection's destroyed in 1906. So really, we don't even get mammal collections in California museums till post-1900. Well, a lot has happened, right? 50 years earlier was the fur rush. I should say 150 to 50 years earlier was the California fur rush. On museum specimens, there was one in the Museum of Vertebrate Zoology, but Grinnell ignored it. It was collected by Dr. John Hornung, a zoologist with the Los Angeles Museum of Natural History. He shot this beaver in 1906 on Sespe Creek, which I mentioned earlier. So now we're in a coastal tributary, a coastal river tributary, the Santa Clara River tributary, Sespe Creek. Most of his collections went to the California Academy of Sciences, which again were destroyed in 1906. What's really nifty is the Chris Conroy, Dr. Conroy, the mammal curator at the MVZ, not only has now got all his specimens online, but he's digitized the correspondence. He actually helped me find the correspondence between Grinnell and Hornung, where Grinnell said, what about that beaver skull you sent me from 1906 on? Was that real? And Hornung writes back, yeah, in 1914, he writes back, yeah, I murdered the specimen in question. 3 miles east of Cold Springs, this is Sespe Creek. I was on horseback, looked like a dead large dog surrounded by a big stump. The stump was swimming, and I reached it. I could see its teeth. I knew what an unexpected find I had made. And he shot it and secured the skull, which you have. In spite of this letter is 1914. Grinnell still doesn't write about it in his 1937 book, Fur-Bearing Mammals of California. And add to that, Hornung says, in fact, there's still quite a few beaver in Southern California. I myself being so lucky to get a hold of one as late as December, Christmas Eve, 1913, 3 weeks ago. So interesting how the shifting baseline sort of barrier psychological thinking also occurred to us, okay, if California's museum specimens are so limited, let's look outside of California. And in the Smithsonian, we found another beaver skull, collected in 1855 in Silicon Valley on Saratoga Creek. Of course, James Graham Cooper, MD, was a naturalist, physician naturalist with the California Geological Survey. He traveled the state on the survey basically during the Civil War. But he spent 3 months in 1855 in Mountain View, and he hunted specimens on Quito Creek, where this specimen came from. Quito Creek is a historic name for Saratoga Creek. So now we have 2 museum specimens, one in the MVZ, one in the Smithsonian, of beaver in basically coastal watersheds. I consider the San Francisco Bay as coastal. What about place names for beaver? So moving to this supplemental evidence, lots of place names for beaver. You don't know if Beaver Creek in Humboldt County was named for somebody named John Beaver or named after the animal beaver, but there are so many, including some indigenous peoples. Here's a Chumash Beaver Lake, that it starts to get compelling from the northern part of the state to the southern part of the state. More ethnographic evidence. This shaman's rainmaking kit, this is Chumash, and it's made from beaver tail. The pictograph in Painted Rock, the Sierra Madre Mountains House of the Sun, this is Clayama River watershed, just flowing into Santa Barbara County, I believe. And then what about indigenous peoples' words for beaver? Again, you see them across the state from north to south and from east to west. Now that doesn't mean they weren't maybe traded, maybe they knew a beaver traded from the Central Valley, but if you dig deeper, you'll find beaver ceremonies and other beaver artifacts supporting that they all had beaver, north to south. The further south report, another physician naturalist, David Hoffman, he's managing the medical clinic at a US Army barracks in San Diego. And in 1866, he writes about the fauna of San Diego County. Of the animal kingdom, we have a fair variety: grizzly, antelope, deer, polecat, the beaver, wildcat, otter. So he's distinguishing beaver and otter here, which is important to see both. There's a Beaver Hollow Creek place name and a newspaper article. A beaver weighing 40 pounds was on exhibit on 5th Street in downtown San Diego in 1889. Eli Asarian helped us build these wonderful maps, which are coded to show you the level of evidence. Is it documented historical record, Z for zooarchaeological specimen, and for museum specimen. And you basically see lots of evidence, any one of which may not be compelling, but in the aggregate, now moving south to North Bay, Central and South Bay, an M for the Smithsonian beaver skull collected on Saratoga Creek. And then getting down to San Diego, in SoCal, the museum specimen here on Sespe Creek, and some fairly credible accounts in many, many places. So we basically changed the historic range map. The historic range here coded greenish, leaving out the arid deserts, even though we know today there are beaver on the Mojave River, not just the Colorado River, and other desert and semi-arid rivers that flow through the deserts. And I'll just sum in a couple things, and then I have one slide after this. The absence of evidence is not evidence for absence. If the habitat's suitable, we need to ask questions and dig deeper, and not just accept conventional thinking about what species lived where. This can be true for swans, for jaguar, for gray wolves. Oh my gosh, did you all see? A gray wolf, Oregon 93, the 93rd radio-collared gray wolf in Oregon just reached the California coast in San Luis Obispo County. Came down, crossed Interstate 5 into San Benito County, then Monterey County, and 2 days ago reached a coastal county, San Luis Obispo County. Nobody thought that was going to happen. Again, individual pieces of evidence could be challenged, I think, in our publications, but in the aggregate, it's overwhelming evidence. And I want to touch on this California fur rush. There's a Wikipedia page dedicated to it. When the Russians came down and started stripping the coast of sea otter, the Boston sailors and traders came shortly thereafter, and they put to shore and offered the indigenous peoples trinkets in exchange for pelts of all kinds, beavers, wolves. I believe the California coast was stripped of beaver first, before Jedediah Smith comes. Jedediah Smith comes in 1828, hunts the Central Valley, and then goes from Napa up the California coast and says, you know, there are very few beaver here on the Northern California coast. You find some, including at the mouth of Klamath, but not many. I believe it's because the coast was stripped. And this is true, I think, for much of our early historical fauna in California. And then, of course, the mountain men strip the Sierras. And lastly, were there beaver in my stream? Well, a few years ago, at the mouth of my stream, Adobe Creek here in Santa Clara County, Richard Stilwell got a picture of beaver tracks at the mouth. This is the Baylands mudflats, and you see this characteristic beaver tail being dragged through the mud with the tracks on either side. So they are coming back. And the bay is gradually getting recolonized in the north from Alhambra Creek and Martinez to the Napa River to Sonoma Creek. And in the south, they're coming down from Lexington Reservoir, where they were translocated in the 80s, and are now using the bay basically to migrate up and down the sides. So thank you very much.
Wow. Thank you, Rick. Such a pleasure to hear you speak again, and thanks for narrating such an amazing story. I know there's some questions in there having to do with questions around the pre-colonial beaver population estimates that span between 460 million. And I think relative to time right now, I'm not sure we should take that one up, as there's a bunch of variables with respect to how those North American estimates get made. And in the Q&A at the end, I would venture to guess between Rick and maybe Michael and others, Ben, I have thoughts on that. And so in the interest of trying to just catch up here, because we've got a jam-packed agenda, I'm going to thank you, Rick, for that. And we are going to just scoot ourselves right on over to Mr. Jeff Baldwin. And we're going to hear from Jeff, and I'm going to let him take it away. Thank you, Jeff.
Great, thank you. Yeah, a little bit behind here, but I'll see if we can catch us up a little bit. And I do want to remind folks that we have scheduled this webinar to go till 6 o'clock. And so we have time after the presentations to have a discussion with all who are interested in that. So this is an extension of an article I published a few years ago in California Fish and Game. And so if you want to look more carefully at some of where I'm going to go, well, you can see it there. I'm going to go fairly quickly because this is more of a synthesis of research rather than my own original research. What I want to look at is what can we expect in terms of climate change that could interact with landscapes that beaver might or now currently inhabit, and how having beaver recolonization could address the damage being done, the changes being made, but also mitigate against climate change, so sequester carbon. So I want to look at both of those things. So let's take a look at this. Atmospheric temperatures in California, as you probably are not surprised at all about, have been observed to be increasing. And so these are observations over the last few decades of how much warmer it is in the American Southwest than it was in the earlier part of the 20th century. Models say, of course, no surprise, we are looking to continue to increase our average annual temperatures. Couple different models here are studies I want to just review quickly. This is from 2013. They're using 2007 data in a model from 2007, and they're using the highest emission model, so the least optimistic model. And what they see, and they did by using 16 different models and overlapping them and then looking for change, they're able to sort of look at a more granular scale. So they're able to actually look at different highlands in California and sort of go, okay, through the seasons, how much warmer can we anticipate this being in mid-century, in the 2060s? And you can see uniformly, we're looking at getting warmer about 1.5 to about 3 degrees. The summers, the warming is more intense than the winters, but the winters are also warming. The other thing to keep in mind here that some of this warming is about warmer nighttime temperatures. So decreased vernalization, if you're involved with agriculture as you go up a little bit in elevation, problematic for farms and farming. The more recent study, UVs, they take what the International Panel on Climate Change called representative concentration pathways, and the more emissions, the higher emissions pathway is that red one at the top there, and I'm going to refer to that in a minute. I saw in the paper today that we reached 421 parts per million at Mauna Loa this year, so we're right on track with the red line there. So we've got one modeling group here, but they're using two different scenarios here. This is a bit more optimistic. So in 20 to 40 years, we're looking at this kind of temperature change in degrees Fahrenheit in California. And by the end of the century, we're looking at this much temperature change. Now, this is going to change how much snowfall we have and how long that snow is going to last. And keep in mind that California gets somewhere around 30% of all this fresh water from melting snows. So this is a giant reservoir that we have in our mountains. The more pessimistic, less optimistic model, which seems to be the model that we are following fairly frequently, fairly well, looks more like this. So we're looking at 2 to 3 degrees increase in temperature across almost all of California by mid-century. And by the end of the century, we're looking at 6 to 7 degrees increase in Fahrenheit, so 3 to 4 degrees centigrade. So what effect does this have on snow and precipitation? Well, again, Pierce doing this granular look, combining a bunch of models, putting them together, statistical analysis, and what we see is that, well, winters across the highlands in California, wetter until we get to the south, where maybe not as wet. Springs, we're looking at drier springs, and we have fairly good agreement amongst the models that springs are going to get drier, which means less snowfall in March and April, which is about water coming down the mountains in July and August. And then in summer, well, not much agreement on the models here. In the north, we see, well, it may get really dry, it may get wetter. In the south, it might get wetter. But remember that if we're talking about California in the summer, we're talking about 1 or 2 inches, and having 20% more than 1 or 2 inches isn't much water. So it's really that winter and summer that we're looking at here. And then there's this. Recent study looked at, okay, so we know how many days a year we get snow. Let's go ahead and project that out with temperature and with models for precipitation and see, well, how much of that snow is going to fall as rain in the future, which means it will not be available to melt down and feed us water in our summertime. So this is comparing observed 1979 to 2012 to model. And again, this is a higher emission model that they're using. If the colors are blue or red, that means rain. If the colors are white, that means we're getting snowfall during that time. And you can see early in the season, December, the area that we're getting snowfall in the past, quite expansive in the American Southwest, but boy, look at how it changes. And then in January, well, perhaps even more market change there. And we get more and more rainfall across the American Southwest here. Perhaps most important for summer water is what's happening in March and April. And what you can see is those areas of blue and red are more dominant when we look at the projection. And we're just going out 15 or 20 years here. This isn't going out to the end of the century. So we're switching to rain. So even though we may get more precipitation, according to some of the models, that precipitation may be falling as rain rather than snow. And so we're not building up this reservoir of potential snow melt. In fact, we may be getting rain on snow events. And when that happens, quite often the rain, which can happen in December, January, will melt the snow. And so we get a smaller and smaller snowpack, no problem. And then there are these two things that aren't even in the models. So we have observed that the water off the California coast is getting warmer. And so what we have here is in the black line observations, in the red line 5-year, 10-year averages, and then extending off to the side there, we have projections. We're looking at warmer water off the coast of California. Meteorologically, what this means is this. So this is observed sea surface temperature anomalies a year and a half ago. And when you get this much warm water off the coast, what it does is it bleeds off some of that thermal energy to the atmosphere. It warms the atmosphere, causes the atmosphere to rise, and it makes this wonderful dome of high pressure here, which steers those storms off to the north. And in the summer, we get the same thing. It steers those storms off to the north. This is not in the models. This is new information. It hasn't been built into the model. So this is on top of what I was just showing about the models. And then there's this. Observations, again, not built into the models yet. We are entering another multi-decadal, it would appear, multi-decadal drought. We call these mega droughts. And we have record of this by looking at plant life and what was living, what elevation, where in California, so we can interpolate how much soil moisture we had available. And we've had these mega droughts in the past. We are entering another one now. Take home is we're looking at having less and less snow at high elevation in April when it starts melting to feed spring runoff and then summer runoff to give water to the lowlands during our dry period. Snow water equivalent looks like this. So this is April 1st, and if it's yellow, that means we have 500 millimeters, 19 inches of the equivalent of water across that landscape. There's 19 inches of water just sitting there. It's in the form of snow, but it's just sitting there. For the next 3-4 months, it's just going to melt and feed our streams and feed our industry and feed our agriculture and give us water. Thank you very much. But if we look at what is expected to happen, projected is, well, we're going to lose 300 or 400 millimeters of water. So by April 1st, we're not going to have much water in the high mountains. And so what does that do for runoff? Well, we've got another model projected for that. We had all have done these last 3 here. Currently, if it's red, about 90% of the precipitation in these areas and the runoff from that is in the form of snow. And you can see in the highlands in California, boy, lots of snow being accumulated there for spring and summer runoff. This is projection near the end of the century. So we're looking at having less runoff, earlier melting, earlier runoff, which then brings us to this last point, stream recession. So when I started looking at this, I wasn't really familiar with the term stream recession. So being a geographer, you delve into things and you learn about things, right? So it's rather obvious when you think about it. We get these floods, these spates in the spring from the snow water melt, and it raises the level of the streams. So that quite often the streams will actually overtop their banks and then connect with the terraces on the other side and get those nice and wet, charge the groundwater there, and then it slowly drops. And as it drops down that bank, well, it creates habitats. And these habitats have saturated or nearly saturated soils at first, and then they dry out. And it turns out that there are all kinds of animals and plants that are adapted to, in the spring, having those drying, wet to drying environments. Lee then took all their information from snow water equivalent melting periods, and they projected this out. Under the most optimistic, or I'm sorry, under a more optimistic scenario for climate change, we're looking at having, well, we have peak flows in the spring from the Sierra here now. Well, it's going to come a week or 2 earlier if we continue to emit and warm our atmosphere as much as we're doing now. We're going to get our peak flow early April rather than into, well, May and June. And then the magnitude of those flows is going to drop significantly also. So stream recession becomes a problem. Earlier flooding becomes a problem. Stream recession becomes a problem. What uses stream recession? Well, these are different studies that look at what species use these areas that are affected by recession during the spring. And what these studies have all found was that it's important for many species that are plants in riparian areas. If we don't have it on time, at the right time, or we don't have it, they won't be able to seed. There's nutrient loading that happens through this process. There's primary productivity that happens along stream banks in riparian forests. There is arthropod abundance that happens as a result of this spring recession. There is salmon spawning activity that is facilitated by stream recession in the spring, and this affects various trophic chains. So it's not just that stream, but there are things that live in that stream or on that stream bank that then affect communities beyond that. Geomorphologically, in terms of the shape of the stream, what studies have found is that if we have earlier, more rigorous spring spates, we change the actual structure of the banks and we get steeper banks. We also get warmer water, and then we get young amphibians that get stranded in well ponds that are no longer wet. So what can beaver do to help mitigate this? Let's look at flood and stream recession attenuation. How can they mitigate against this smaller spring flood and the earlier spring flood? Well, it turns out that willows and beaver are kind of co-adaptive. If the beaver chews a willow, it tends to sprout several more sprouts where that willow branch used to be. And as a result, having beaver grazing on willow actually cultivates willow. We can get up as much as 10 times more biomass from the same willow plant that is being chewed occasionally by a beaver. And if we have no willow, if we have no beaver, if we got elk, it's much worse than that. So elk are really bad about this. And the willows tend to grow 1.5, 2 meters tall. And they form these cards, which are really thick branches, and it turns out that those actually slow water down themselves. So it's not just the beaver dam that slows the water, it's the willow cards slow the water. Study by Trimble and Albert found that 6 to 14 years after beaver recolonized an area, willow cover was extensive all the way across the floodplain, not just on the banks, but all the way across the floodplain, right? Baker found that by simulating beaver browse, and so what they do is clip the willow as if a beaver would clip it, keeping the elk out of there, increased biomass, well, it doubled in 3 years with simulated beaver clipping. Willows are cultivated by beaver. Beaver encourage willows. And then I saw this just recently, fascinating. Levine and Meyer, they're working in southwestern Montana at 2 different sites. And it turns out that willow, like some other plants, that if you clip it and then put it in the appropriate place, that clipping will set root and it will live there. And what these folks found was that where we have point bars and streams, well, so a stream flowing down this way, the most rapid flow tends to be where it's dotted here in what we call the fall wag, the deepest part of the stream. And so it hits this bank over here and it sort of erodes that. We call that a cut bank. Not much energy over here. And so quite often, if there are beaver working up here, some of their clippings end up here on this point bar. And it turns out that after a while, some of those willow clippings actually take root on that point bar and work to extend that point bar, which means that beaver create more meandering in streams. And the more a stream meanders, the more it's going to tend to just dump its banks when it's that high flow and flood that riparian area and flood that floodplain and charge that aquifer. And so we get willow growing there. They farm willow. Why does this matter? Especially, well, studies show that if you have enough willow, it can actually slow down floods. It captures, because it's slowing down the flood, it also causes deposition of the sediment in the flood. So this is a way that beaver can slow down floods and hold on to the water, but then also build up banks, have more sedimentation, build that area that have been sized back up, right? In Bridge Creek, what researchers found was that, well, quite often beaver dams don't survive floods. They don't survive the spring spates because there's just too much energy there. But even where there are beaver dam remnants, it still tends to divert the water off to the side, where it goes in the groundwater and then slowly flows back into the main stream. And we have this computer model by this fellow in graduate school working up in Alaska in the Aleutian Islands. And what he did was he modeled having beaver dams. And what he found was that, well, one dam doesn't do that much with the flood, but if you actually have a succession of beaver dams, which is what happens when you have good habitat for beaver, well, it can actually retain a fair amount, I'm talking 10, 15% of those floodwaters in place. So that's water available in the groundwater for trees after it dries out. What about cooler flows? Just briefly, well, I won't spend a lot of time on this. You can read about it in my paper if you want to. This study looked at the Feather River, and they looked at different elevation areas of the Feather River, and they said, what happens if it warms up 1 degree centigrade? the atmosphere. How warm does the water get? At what elevation? What if it warms up 2 degrees centigrade? How warm does the water get? And what they found was that, well, currently 20% of that river system is above 21 degrees centigrade in summer. It's too warm for salmon. If we warm it up 2 degrees, the atmosphere, 57% of that stream is too warm for salmon. If it warms up 4 degrees, salmon can't live there anymore. Beaver can help refrigerate streams. Water has a high specific heat capacity. It doesn't give off its thermal energy very easily. And so when water goes into the groundwater behind a beaver dam during spring spate, when the water is really cold, as it flows through the aquifer, it doesn't give off much of it doesn't take on a lot of the thermal energy from the ground around it. When it re-enters the stream, it's still cool. It re-enters the stream 1, 2, 3 months after it goes underground, which means we have this cool water coming back into the stream at a time when the stream is warming up. It helps cool down the stream. Habitat enhancement, what can beaver do around that? Well, okay, if we look at what happens if we change stream recession, alter stream recession, beaver ponds address every one of these. Now, it's not going to mitigate all of this, but it provides refugia where we have beaver for those plants and animals that used to use the recession at the time of year when we have recession. So we get riparian seeding, we get nutrient loading in the ponds, we get primary productivity around the ponds, we get anthropod abundance around the ponds, right? You get the idea. And then because we have willow cars, if we have beaver there, well, that's going to address these problems with higher water temperature, changes in the stream bed and its shape. And then there's this, in terms of habitat. Beaver ponds are very good places to grow if you're a water lily, a duck potato, duckweed, waterweed, if you are an herbaceous plant like forbs, sedges, and grasses, or if you are a woody species like aspen, willow, and cottonwood. All of these like beaver ponds. And guess what? This is the order of things that beaver like to eat. Trees are not the first thing beaver eat, right? It's these plants that grow in the pond. You might say that beaver are farming the food that they grow because they are creating the environment in which the food that they like to eat grows. Okay? Last point is this, carbon sequestration. Several different studies, and I won't go through the details here. You can read about that in the article if you want. Several different studies have found that in the soils that accumulate behind beaver ponds that eventually build up and form wet beaver meadows if the dam stays there long enough, because the sediment's so very fine, it absorbs nutrients extremely effectively. So if you look at beaver ponds and beaver meadows and former beaver meadows, what you find is nitrogen can be as high as 6 times higher than the hillsides around there. We get phosphorus building up in there and we get carbon building up in there. A recent study by Norton was looking at meadows in Sierra Nevada and how much carbon was in the meadow soil compared to the soil around the meadows. And what they found was that in the High Sierra in California, 12% of all the carbon stored in all that soil is in those little meadows. There's 7 times more carbon in a meadow soil profile than in an Oman meadow profile. Carbon sequestration. This is something else that beaver can do to address this. So these small creatures have all kinds of things that they can add to our well-being as well as well-being of the environment out there. That's what I got for you.
Woo-wee. Oh my. Wow, thank you, Jeff. That's amazing. I love all that data. It's amazing. All righty. We're gonna just keep this train rolling and move and keep the willow cars going. We're gonna ban carbon and go to the willow carbon storage and move ourselves right on over to, I'm super excited that we have Trina Cunningham with us today. And Trina is the director of the Maidu Summit Consortium, and we're going to hear from her about their work up in the primarily in the Feather River system, but she may tell us more about that. But thank you, Trina, for being here with us, and I'll turn this over to you.
All righty, Hasasakari. I'm very pleased to be here, and actually very excited as a tribal person living in my indigenous homelands since birth and following in the exact same footprints as my ancestors. I'm very, very excited to be here. And one of the reasons is that as a tribal community, beaver, porcupines, and other species, to even name them caused so much controversy that it was debilitating at some levels. And I would equate it also to the erasure of us, of our existence and our knowledge systems. And so it's exciting to be part of a movement to acknowledge, recognize, and build on the knowledge that we have left here. So today, I want to talk to you a little bit about a place called Tasmamkoyom, and it's in Plumas County, as you can see on the video. And this was a very significant place for us as Maidu people, but it was also known as an intertribal trading place with other tribes as well. And this was an area that we did restoration on recently in partnership with a lot of other people on meadows and beaver habitat. So Tasmamkoyom is our name for this valley that's a little bit over 2,300 acres, and that we've always lived in and that we continue to visit. And beyond that, through the recent divestiture process from PG&E's bankruptcy in the early 2000s, we recently acquired this landscape back to our ownership. The Maidu Summit Consortium was formed to be able to hold this property and to gain ownership of it. And we are very, very excited to be able to bring our people back together and to reinstitute traditional ecology and our knowledge systems. As a place-based people, this is really essential to doing this. And so I thank all the previous presenters for leading me up to this point. We do in fact have a word for beaver, and it's hichichi in our language. And hichichina was is in part of our creation stories. And so we know that beaver has always been here since before we were, and we hope that they will continue to be here. And so this isn't just about beavers, although it's a pretty cute but ferocious little animal. This is also about restoring the habitat. And so the quaking aspen is one of those habitats that we want to restore. And this is one of the favorite munchables of beavers, Sililikamcha. And it's a beautiful plant, and the root systems are incredible and also help to hold water and are an essential component of meadow restoration at these elevations. Another of their favorite nibbleables are the black cottonwood trees, lilimcha. And I grew up in a place called Yatomatopoyo, which is in Genesee Valley, which is where some of the river from Red Clover Valley that was mentioned earlier runs through that valley. And so it was just very common for me to see alders and cottonwoods in the riparian bottoms, along with gray willow and other things that were really essential part of our culture, needs, edibles, medicines, musical instruments, and many other things that we'd like to see restored in Tasmamkoyom, as well as everywhere in the Upper Feather River watershed, which is basically our ancestral homeland. And this is a picture of Big Spring. It's an amazing sacred, one of the most sacred sites in that area. And but there's a nesting pair of, well, it's an adult bald eagle directly down from the arrow, and just to its right is a larger juvenile eagle. And so it is about balance and species interactions in the ecosystem, and diversity of all of the, what we would say MIDEM, all of the people, including the non-human people. And as human beings in this landscape, we often become arrogant and egocentric, and not realizing that we are just part of the story and the overall story, and that we will soon be gone. And so what we leave also becomes part of the story. And I would like us to write a very good story. As a young child, I had the opportunity. At that point, we still had fluent speakers in our language that knew the old stories and some of the creation stories. And I thought they were all jokes, because oftentimes I couldn't quite understand what they were saying, but they sure laughed a lot. And even over some of the most critical and difficult conversations, they would laugh. And one of the things they talked about were frogs. And frogs, I quickly learned, are an indicator of water health. And so as we're looking at restoration and what we're calling conservation, as tribal people, we would call it maintenance and stewardship. Like, it's all about building a relationship with a place and really knowing those places and tending them to their optimal values and optimal health. And again, we have meadow systems that are depleted of some of the natural resources that supported the biodiversity that we want to achieve. And so in order to create that space and reintroduce, bring things back home to where they belong, we have to create that whole system of food, clean water, and those relationships. And so things like wild potatoes and camas and celery and carrots, onions that don't grow in the riparian area. Well, swamp onions do, but there's a lot of species that are interdependent on each other that are critical to our area, as well as seasonality. So in the fall of 2020, the Maidu Summit Consortium had been working with Swiftwater Design, OEAC, California Department of Fish and Wildlife, and many other local Maidu and non-Maidu volunteers to do some restoration in Tasmamkoyom. And they also, we worked with Sierra Fund to do, and some science-based academia and other folks in Red Clover Valley, which was mentioned earlier today, and it's in our upper watershed just above Yatoma Tokoya, where I grew up. And so it was my backyard growing up in. And so we started building BDAs with the expertise of these partners. And I wasn't able to participate directly in them because I was on fire assignment and was in Colorado fighting fire at the time. But I was bummed to miss it, but really excited that these projects are happening and moving forward. So you see here our chairman of the Maidu Summit Consortium, Ben Cunningham. He's my dad's cousin, and then others out working. So in all, they made 73 handmade beaver dams. So they had to find materials off-site and bring them in and do the construction. And it looks really exciting to me. And also of importance to us as tribal people is there have been a series of pond and plugs and other methodologies used to slow water down in meadow systems, but it really contributes more to sedimentation and does a lot of destruction to our cultural resources. You know, when you have D-tins and bulldozers and heavy equipment in stream areas, it's not our preferred way of doing things. And so the tools and methods having low impact and low energy consumption are really important to us. And also it really gives people that chance to truly build a relationship with a place that they wouldn't have if they're sitting on a D10. You would, but it's just not the same. And working side by side and finding and sourcing the materials and thinking of the consequences of taking them from a place that's a terrific experiment. And so the outcome doesn't quite look like a beaver dam, but boy, if some of those hold during high water events and help slow down the erosion, catch sediments, and build up the river bottoms, that would be a good measurable. So some of the tribal methodologies are measured over a span of time, and that span of time may take a few moments that you can see changes. Sometimes it can be very, very dramatic. But then it really doesn't need to be measured, you know, over a sequence of days, months, and years. And once we build something like this, or do like a fire treatment, or we landscape burn an area as part of restoration, or getting rid of invasive species, forest health type of projects, we need to go back in and check it. And it's kind of like, was it Rick Landman that in the earlier presentation was talking about the red clover dams that they found up there. And I believe that was around 1986. And the dam itself was, I think, let's see, I have it in my notes. Well, the dam itself had 4 feet of soil over the top of it when they found it. And so there was kind of an argument of, well, that's a beaver dam, obviously. And others were like, no, beavers didn't exist here. It can't be a beaver dam. And so that's part of why they radiocarboned it. But and so if you think about that, and you have a beaver dam at a certain height, and then for an amount of years, 4 feet of soils and sediments get trapped into it. And then at some point it did blow out. But the capturing and the contribution of beavers to slowing water down, helping water temperature, maintaining flows year round, larger wetlands, sourcing more habitat and biodiversity were critical in our areas. And to be a part of a process of reinstalling these is exciting for our whole community. And one of the highlights for me was talking to a youth that had participated in that. And as I said, I didn't get to directly participate. So I'm like, okay, I'm gonna do a presentation that I wasn't directly a part of. So I really wanted to highlight other people and their experiences. And as you can see from these photos, there was quite a large group of people. But Sophia Williams, she was one of our youth volunteers who's tribal and lives in the Lake Almanor Basin area. And just after an hour of the analogs being built, the stream began to rise. Building the analogs was a lot of work, but it was rewarding. And finding ways to engage our youth of you know, all youth throughout California or any state or anywhere in the world that we're in is essential also to this process. And for tribal people, that is one of the biggest things that we are facing, is that loss of generational knowledge. And so developing mechanisms for mentorship, and not just mentorship with our tribal elders, but mentorship with other areas of expertise, whether it be science and academia, or gurus that, like Kevin Swift, who just loves doing this type of work, and having them be around those passionate people, and learning and connecting them back with themselves so that they can go forward into the world, and hopefully in a better way than we were handed growing up, with that loss of connectivity and loss of elders. I think my children, who are in their 20s, didn't have that real opportunity to listen to fluent speakers, and so we're at that point of urgency to reconnect those knowledge systems. And so this is one of the ways that we can do it. And we really appreciate the opportunity to learn and to grow together. And one of there's many issues with working with tribes, and some of the issues for us is that we haven't had the opportunity to truly put our knowledge to active use on a landscape. And we often work in partnerships that are driven by other people. And so one of the goals on our landscapes, Tasmamquayam is a little over 2,300 acres, but we're also, we just closed on another parcel at 296 acres on March 24th. And so our properties right now are right around 2,800 acres. And some of them are, this is the largest parcel, but some of them, each one is a very unique ecosystem, and with diversity opportunities. And so to fully engage our Maidu communities and our knowledge systems means bringing them out to these places and asking, what is your relationship here? What is your knowledge here? Did your family tend a specific place? And if so, are you willing to share where they tended it, or why they tended it, what they tended it for, and to give people the opportunity to be heard, but also to put that into our land management plans so that it is truly tribally driven. And that also comes with, oftentimes in my experience, agencies go to one person. They want one person to talk to. And in tribal communities, you might, see an agency presenting a landscape scale plan to one elder and asking them what they know about all these places. And that elder will know a lot about a few places and then really not know much about another place. And so then the person says, okay, well, no concerns there. Good, I'm on my way. And that's just not how we need things to be done. Many of these places have been tended for hundreds, if not thousands of years by one family. And if that family isn't asked and somebody else responds saying, well, I don't really know, so, and they don't reach out to the family that does have that knowledge, we continue to have a huge amount of marginalization. And this idea of TEK, traditional ecological knowledge, is really important, because it is our ancestral knowledge. It's knowledge derived from our creation stories, telling us how to be in this world. It's refined knowledge about specific places and species and their interaction, interdependence on each other. And it has to come from the people from the place. There are people that are out saying they're TEK specialists, and they're working in other people's tribal landscapes without those tribal people's knowledge even sometimes. Or even in our own landscapes, like that example of going to that elder, that elder should be respected and they should be included, but is important that when you're talking to tribal communities, realizing and recognizing that it is a whole community. And if you're talking to one or two individuals, be it just me or anybody else, it's not sufficient. And some people are better at reaching out if they get a question, reaching out to their community, and others just, I think they just don't think about it. And so these are important things. And it is important also that as you're looking at projects and project development around, you know, with anything that you do, work with that local tribal community and budget in their time and expertise. And it probably needs to be more than 10 hours in most cases. So we're really excited to look at the redeveloping our relationship to those places. And in our creation story, it talks about knowing these places, going out and naming each place, knowing every nook, every cranny, every spring, every species, giving them a name. And that way we'll always know ourselves and we'll always know our pathway in the world. And I truly believe that some of the misdirection in the world now comes from not knowing our place. And so it's partnerships like this that gives us all an opportunity to do these things together. So we need the room as the space as tribal people to reconnect to each other and to our own knowledge. But we're also very, very interested in building allies and partnerships. So we know that beavers have been here. If you look at the bank on that beautiful, beautiful photo, there's not a lot of habitat there to support having a beaver swim up the river and decide to make that a home. And we look forward to that day when we see the first beavers swimming through those rivers again. Thank you.
Wow. Thank you, Trina. So good to see you back. I know everyone missed you when you were on fire in Colorado. That's for sure.
It was a great assignment.
Yeah. Well, the beavers will come back. And Kate's going to talk a little bit more about that. And I did put the link to the strategy we worked on behalf of the Mighty Summit Consortium in the chat for people to have a look at after this. So we are going to continue on. Thank you, Trina, there. And just keep this train running. And someone who's worked a lot in Tasmam and other places is Karen Pope. And so we're going to hear from Karen. And she's just going to leap right on this presentation because she's a froggy like person like me. All right. Welcome, Karen. Thank you.
All right. Thanks, Brock. Oops. Did I mess it up? Can you see my screen?
Still
No.
you.
All right.
Yep.
There we go. Now we're on. Yep.
All right. Thank you. More talks about beaver. So my name's Karen Pope, and I'm a research aquatic ecologist with the U.S. Forest Service Pacific Southwest Research Station. I'm based out of the Redwood Sciences Lab, which is located behind Humboldt State Campus and in the beautiful north coast of California on the native lands of the Wiyot and the Yurok. And I'm excited to talk to you about beaver and biodiversity in general, but with a focus on amphibians and birds. So without further ado, I'll just jump in, see if I can change my slides, and introduce you to the willow flycatcher first. Let's see, trying to get rid of that on my screen. It's a wetland obligate songbird that nests in riparian shrub habitats in meadows and streams throughout California, the mountains especially, and it has become rare along with its declining habitats and is now considered endangered in the state of California. And then next we have two riparian frogs, two ranid frogs, that are both declining as well. On the top is the Cascades frog, and that occurs in the Northern California mountains, so the Klamath and the Southern Cascades. And then the Sierra Nevada yellow-legged frog, which occurs in the higher elevations of the Sierra Nevada. The Cascades frog is under review for listing as endangered by both the state and the U.S. Fish and Wildlife Service. And the Sierra Nevada yellow-legged frog is listed as endangered by both. And both species are highly aquatic and occur in wet meadows and lakes. So interestingly, the threat list for both songbirds in California and amphibians in California are basically the same. Maybe one is more important than the other, but really habitat loss, non-native species, wildlife diseases, climate change, and environmental toxicants are all really important threats to both songbirds and amphibians. And so, that brings the question, so what can this, oversized rodent that's really clumsy do for these species given these threats? And to make that point, I just want to show this video that was captured by Jen McKeith and Daniel Hawaii at Jody Ravine at Beaver Base Restoration Club. So as you know, with all their clumsiness, beaver are amazing ecosystem engineers. And just to show, I've put up three of many papers on the topic of beaver and biodiversity. And beaver have even been proposed as surrogates for conservation of amphibians throughout North America. But I want to focus in on this one recent paper by Romancic et al. In Freshwater Biology, and they studied amphibian use of dammed and undammed habitats in Washington. And they found that the driver of increased species richness behind beaver dams was in part due to the presence of slow developing amphibian species. So those that take longer to metamorphose. And that's related, of course, to hydroperiod and the increased hydroperiod created by these dams. And Cascades frogs, Sierra Nevada yellow-legged frogs, both are very slow developing. Sierra Nevada yellow-legged frogs even have a 2+ year larval stage, so they need that permanent water. But what it also means is that American bullfrogs that are also slow developing could potentially be benefit from beaver dams. And so I just want to put in a little word of caution that when we move forward with beaver-based restoration, that it's important to know what species are occurring in the region. And if there's American bullfrogs nearby, take the time to see about doing control ahead of putting in the beaver or beaver dam analogs or whatever it is, so that we don't add complexity and increase habitat conditions and create improved habitats for invasive species, and really try to focus on our native species and the benefits that we get. Because we know that beaver increase complexity to incredible degrees. And so the volume to surface area ratio, and then also this really important zone of the space of aquatic and terrestrial linkages. And so we can look at forest habitats and look at where the most biodiverse zones are, and they're in those areas of the intersection between, say, a forest and a meadow. And beaver do a great job of creating habitats that intersperse terrestrial and aquatic habitats. And those conditions really create productive landscapes for both plants and then insects that feed our amphibians and our birds. All right, so I'm just going to jump into a little bit of detail on some of the studies that back this information up. A bunch of us did a study at Childs Meadow, which is adjacent to Lassen Volcanic National Park. And it's a beautiful big meadow right along the highway. So it's this great demonstration site. And we did a little experiment where we had 4 different reaches that we studied from hydrology, carbon sequestration, a bunch of different variables, including amphibians. And this upper reach was our negative control where grazing occurred and we didn't do any restoration. The third one, we excluded cattle, but didn't do any restoration. The second one, we put in 6 BDAs. And then this lower reach that's separate was our beaver control reach. So no grazing and beaver present. And these dots, the red dots are Cascades frog breeding sites. And the blue to white dots are Cascades frog occurrences during surveys. And you know, the bottom line is that the frogs occurred where the beaver were. And so that was the primary take-home message. And if we zoom in on that beaver habitat, what we see first is, you know, beaver don't just dam the channel. They often will continue their dam at even a couple inches high across the meadow. And what that does is create all kinds of both deep water and shallow water habitats. And these shallow water habitats that have long hydro periods are perfect for breeding sites of Cascades frogs. So these orange yellow polygons are breeding sites for Cascades frog. And then there's also the nursery habitats nearby where the frogs can use the slow water, still water habitats without having to interact too much with adults that tend to occur more in the deeper water and often in flowing water. So to zoom in that same site and look at, so the orange dots are juvenile frogs or recently metamorphosed frogs, and the green are the older. And here again is that dam. You can barely see it, so I've drawn it in for you. And so these frogs are emerging from these shallow water breeding habitats that the beaver created. And this is in 2015 when the beaver were actively maintaining this site. And it turns out that during this study, we had a rain on snow event in January 2017, and it blew out several of the beaver dams in the system, including this one. And so by the summer of 2017, you can see this dam was blown out, the water's gone from here, and the frogs had to quickly adapt to the changing landscape. So while we lost some breeding habitat on that edge because the water drained, the frogs still occurred in the area, but relocated. So if I back up real quick, you can see the change. And I also want to point out this region here in the 2 years, you can see that the beaver really focused on the willow in that area in terms of feeding. And so you can see these channels that they built in here to get them. And those remained, of course, after the beaver left. And that's where the frogs now are breeding still to this day. So move on. So moving on to birds, many wetland obligate songbirds in California, you know, with its Mediterranean climate, they rely on habitats maintained by beaver because the increased surface water intermixed with patches of shrubs and dense wetland vegetation provides nesting habitat, perch sites, and importantly, the water provides a barrier to terrestrial predators such as chipmunks that have been really detrimental to a lot of songbirds in California, while also supplying huge amounts of aquatic invertebrates, emerging aquatic invertebrates, to feed both themselves and their young. And Helen Laughlin from the Institute of Bird Populations and Brent Campos and Ryan Burnett at Point Blue did a couple studies to really send that point home. And they looked at zones around Tahoe, both with beavers and without, reaches and streams, and found that when you had beaver dams in the system, that the probability of occupancy by willow flycatcher more than doubled. And looking at song sparrows, this is back in Guernsey Creek, which is the stream flowing through Child's Meadow. They used the natural experiment of that 2017 flood event that blew out a bunch of dams, and they looked at the zone upstream where the dams were rebuilt and downstream where they weren't, and saw that song sparrows territories were about half the size and twice the density in the beaver zones than downstream where there were no beavers. So I can't help but take this, the relationship between beaver and biodiversity, and think about restoration and what we're doing on the landscape in terms of restoring our degraded habitats. And you know, we're just not as good at nature, as good as nature. And there's this paper, but there's also several papers that show that restoration isn't as good as natural systems are, and that we have a recovery debt in which our restored systems still are below natural systems. And so this graph highlights the 30% recovery debt for species diversity. And so as an ecologist, I like to think about this and how we restore systems and what are the natural systems like that we're trying to restore. And we have, you know, the terms resistance and resilience that we use a lot in ecology, and resilience is a buzzword right now. Building resilience, we're trying to build resilience everywhere. And so I apologize for that, but it is an important term. And if we think of resistance and natural systems that resist disturbance, we often can think of old growth systems, those systems that are really strong against storms. And in aquatic systems, there are old growth wetland and riparian systems. And then we can move along that and head towards resilient systems. And beaver meadows create that sort of balance between resistance and resilience. They are hit by big storms, they resist small ones, and then once those storms pass, they often rebuild. And so you get a resilient system. And then on the bottom end is like an active low gradient floodplain of a river system that is natural, where every year sediment's going to flow into it, cover it up, and then in the summer plants will regrow. And that's an example of a really resilient system. And it turns out that sort of intermediate habitat is the most biodiverse. And then of course the degraded habitats are down here, and they're not too resistant or too resilient. So if we take that to restoration, we can think of our sort of form-based restoration, our hardscaped restoration, as resistant restoration. And so we build these systems to resist disturbance. We don't want the habitat to be affected by high flows. We want it to still be stable. And then we head towards the beaver-based and BDA-based restoration. That's somewhere in between. And then there, you know, stage 0 or anathematizing or the idea that you flatten the valley width and let the water do whatever it does is the idea of stage 0. restoration where you don't really have any primary stream channel. And, you know, I kind of blame the Three Little Pigs for what we've been doing because we grew up on this idea that we have to work hard and we have to use bricks. And we have to hold back the big bad wolf. And so it's really hard to lose that and to say, no, you know, I'm going to use sticks for my restoration. So the problem is that our natural systems, when we apply bricks, we're building resistant landscapes when we maybe should be building resilient landscapes. And so we're going to end up with a lot of old growth riparian and old growth wetland habitats that are great for some species, but not all. And we're doing it in zones that have the potential for more. And so I'd like to see this pie chart of what's been implemented in the past really add a bigger slice of orange and gray and take a lesson from Beaver. So in conclusion, Beaver increase habitat complexity and biodiversity. They support conditions for our rare amphibians and birds. And they really can teach us about restoring aquatic systems to maximize biodiversity. And so I encourage us to really think about what we're talking about here and how to apply it to what we do in our jobs. And finally, I just want to acknowledge a whole bunch of people and agencies and nonprofits. And also, I think we're going to hold questions just because we're running a little slow. But I'd love to hear from you and hear your thoughts on it. Thanks, Brock.
Yay. Thank you, Karen. So fun. Yeah, we got a bunch of questions and Jackie is capturing them. And I think we will just keep moving through now with the hope that we'll see what time we have left at the end at 5. And then we'll I mentioned before, but we do have, many of us have the possibility of staying on for at least up till 6 if folks want to stay on and have more conversations. So we'll try to pick that up. So thank you, Karen. And we're gonna shift over to Marjorie Casely from the California Department of Fish and Wildlife. And do we have Marjorie?
Yes, do you see
Oh.
my screen?
There you are. Okay. Thank you for being here. All right.
Great.
Go away.
So you guys see my screen?
Yep.
Yep.
Yeah.
Yeah, great. Well, first of all, I want to say thanks for letting an engineer come and talk to all you great scientists. And I've been learning a lot from all of you, and I really appreciate you having me here. And if you think that Beaver might be a little clumsy, then you haven't seen an engineer in action. We're definitely very clumsy. The other thing I wanted to say is that I think that this talk was originally planned to have someone besides me talk about maybe some policies of the department as related to Beaver. And I've already seen the question about Beaver translocation come up. And, you know, I guess I wanted to just point out from the start that Beaver translocation as in the Fish and Game Code is not allowed in the state of California, and we're the only state in the West that doesn't allow it. And so until we change the Fish and Game Code, we're kind of stuck in this situation. And I'm kind of low down on the totem pole to really talk about how that might get changed. So instead, I'm going to talk more about what the department is doing to move forward on low-tech process-based restoration, which includes beaver dam analogs and other structures, and how we're moving forward on that. So we're working on a paper to streamline our permitting on this type of restoration. And so I want to acknowledge my co-authors, Gary Flossie, Elijah Portugal, and Mark Smelzer, who have been working on this with me. I don't know. There we go. All right. So Karen talked a little bit in the last talk about stage 0, and I just wanted to point out Kluwer and Thorne's paper on the stream evolution model and go through the various stages. And so she was talking about the anastomosing stage 0, which is what is sort of new and hot right now in the restoration community, and beaver dam analogs are often used to get to this stage. And then we have various other stages that streams evolve through. And as I'm sure most of you know, we are mostly in a degraded and arrested degradation state in California, but various places moving through other stages. So the most important thing to take from this is the relative habitat values of these various stages. So as you can see that, and I think that, maybe we're not just talking about habitat for salmonids, but we're talking about amphibians and birds and other species as well. So I think that the other talks have done a great job of covering that. But obviously stage 0 is got the best benefits to the ecosystem. But as we move through the cycle and we get to stage 8, where we're sort of widening out and recreating a stage 0, albeit a lower level, we are also having good ecological benefits. So that's where we're at. So one of the questions that comes up a lot is, do we want to head towards stage 0 or do we want to head towards stage 8? And I would say that this has to do a lot with the project goals, the project risks, and then where you are in the geomorphic setting. So of the goals for process-based restoration and beaver dam analogs, these are the main goals. As we've been talking about today, we want to create more beaver habitat because of all the values that come along with that. But on a more a less focus on the species, but a more lower down maybe in what we're thinking of is floodplain connectivity, hydrologic connectivity, in particular groundwater connectivity and bringing up the groundwater level, and then geomorphic complexity. So those are some of the things that we want to think about as we're deciding whether to go up to stage 0 or out to stage 8. The other things that we want to think about are risks. And so there's been a lot of great work done on process-based restoration and coming up with the right settings and the risks to doing this type of work. And if you look at this, this chart, a lot of it, the bottom half, has to do a lot with what landowners are willing to allow on their property. So in general, we want to stick with the green and sometimes in the yellow terms of risk when we're doing process-based restoration. It's a little bit harder once you get into the red area because people don't want to allow things to move around as much. Other considerations for process-based restoration projects are fish passage. We know that fish generally pass beaver dams, and the department recognizes that. But there are some cases where the project may go wrong and you may have an impact to fish passage. There might be an effect on water temperature in the short term, as you haven't developed the riparian zone to shade the water, and so ponding that water up may have an impact on water temperature. And then you may be in a situation where you are have very limited spawning habitat, and creating beaver dams may impact the availability of spawning habitat. Those are things that aren't common. but they are something that you should give some thought to. So anyway, in terms of risk, the landowners, the property owners may have more willingness to let water come up than to let banks erode, or vice versa. And so that may impact whether or not you want to go stage 0 or stage 8. So Utah State has come up with a program called the BRAT, and it's been basically assesses the suitability of a stream reach to have beaver dam become colonized on the creek. And so here are the various things that BRAT looks at. Things like stream power, things like perennial flow, and also risk to infrastructure. So BRAT can fit into doing your risk assessment when you're doing this. So, and so the last thing that we want to look at after your project goals and after the risks is the geomorphic setting. And so this is where the department has spent a lot of time thinking about what we would like project proponents to look at to determine if beaver dam analogs and other process-based restoration techniques are appropriate. And so I'll get a little bit into that, but generally you want to start looking at the entire valley floor and not just at your stream channel when looking at doing a beaver dam analog project. So already most projects that come into the department to do restoration will have a stream assessment, and so this is just the general assessment that the department already has, as laid out for people to do, and so we consider that it's a good idea to also do this work for areas where you want to do process-based restoration. So we're basically looking at the channel substrate, how entrenched the channel is, the sinuosity, and that type of thing. We're also interested in what's already out there in terms of large woody debris. So that would be a good thing to include. And then the final thing to sort of take into consideration when deciding to go up or out is what your stream banks are made of. And so we go into the mechanics of how stream banks fail and how that changes the stage in the stream evolution model of the creek as the banks fail, and how that process goes along. So now I want to get into how restoration goals might influence the type of process-based restoration structures that you choose. And so when you're looking at enhancing beaver habitat, sometimes you just want to enhance the dams that are there to give them a little bit more stability during large storm events, but other times you might want to start building beaver dam analogs to start affecting your groundwater levels and your colonization of riparian plants. And so that gets into hydrologic connectivity. And in these types of projects and floodplain connectivity, we generally think about going up to stage 0 rather than out to stage 8. And in that case, we're looking at beaver dam analogs. In other cases where we're looking at increasing sinuosity, or in other cases, or protecting certain pieces of infrastructure, we're looking at more deflection type structures. And so I'll get into what those look like in a second. So beaver dam analogs are these channel spanning structures that raise the water level up. And a lot of times beaver dam analogs are built in a pretty close series just downstream. You would have one to protect scour at your main structure and to step down the water surface more gradually. And then the other thing that is done are these post-assisted log structures are these, and they're these constriction dams, which can increase sinuosity. So you can see this one sticking out and can create bank erosion on the opposite bank. And this one is creating a scour pool. So oftentimes these projects, I mean, these structure types are used in concert to create habitat diversity. And then I wanted to get a little bit into the department's philosophy on low-tech process-based restoration. You know, beavers are out there 24/7 doing their maintenance and monitoring and implementing their projects. And it's an ongoing process for beavers, and we want humans to consider that it's ongoing for them as well. And so really, it's important to think about design, implementation, monitoring, and maintenance to be integrated into an ongoing effort. And so again, at Utah State, some folks have come up with, I think it's Utah State, and I apologize if it isn't, a new application for putting on like an iPad or something to help you organize your project. And so you can start with designing your structures where you want them to be. It can help you figure out the quantities of materials that you need in order to build your project. And then it's stored in this application, and you can go back and use this database to do your monitoring and to assess your need for doing maintenance. And so the department just really encourages the use of this application to help ease the organization and the ongoing efforts in your project. We'd like to encourage people to do this monitoring and maintenance on an annual basis at least. And so as a result of that, when implementing this project, these types of projects, we encourage there to be a long-term project manager, not just someone you hire for a year to roll the project out. And then it's good to have a base of volunteers. And so some of the most successful projects have partnered with tribes, also maybe like a Trout Unlimited chapter or college classes or grade school to high school classes or maybe a Rotary Club. But it's important to have a base of people that want to come out and work on these projects as part of their stewardship. So. And then the last thing I wanted to talk about is monitoring of these projects. When you start monitoring the performance of your project, it's good to start actually from an elevated view of how the whole project's performing. And then based on how your whole project's performing, that can really guide you into whether or not individual structures need to have maintenance done to them. But it could be that overall the project's performing really well, and so that even though one structure is sort of blown out, it doesn't necessarily need to be put back to exactly the way it was. And so we really want to take a more global approach to maintenance and to project success, and not base the success of the project based on the persistence of individual structures. So that's what I have on that. So that's what the department is working on in terms of moving forward on trying to do process-based restoration, try to create beaver habitat. I would say, since we're limited on being able to translocate beaver in the state of California, building these beaver dam analogs is a great way to try to get them to expand their footprint. So if you can build them in a neighboring reach or even a neighboring watershed, you may be successful in getting beaver to move over. So for instance, we know that there's beaver on like Sonoma Creek, and that they occasionally cross into tributaries to the Russian River watershed. And so it could be that those tributaries to the Russian River might be a great place to start building beaver dam analogs to encourage the beaver, when they do come over, to stay and colonize. So thank you very much.
Great. Thank you, Marjorie. Thanks for a shout out for those of us who have been in the thick of witnessing that Sonoma Creek Russian River transfer. All righty, we are going to scoot right on over. And Marjorie, I don't know if you can stay hopefully afterwards, because lots of questions for you as well.
Okay.
Hopefully so. All right, all the way in from mighty Massachusetts, we have none other than Mr. Mike Callahan. So bring it on, Mike. Whoop, whoop.
Thank you, Brock. It's a pleasure to be here. So thank you very much. I'll share my screen. And here we go. So yeah, why does it say unmute myself? So what is that? Here we go. So I'm here to talk about how to manage common beaver conflicts, and I'm very grateful for the opportunity, so thank you. And it's based on 23 years of work and resolving over 1,700 conflicts with the water control devices I'll be talking about. So we're going to cram a lot into 20 minutes, so sit tight for the end of the day, hopefully keep you awake. So we've heard about all the benefits of beavers and their dams. And so that's why we want to, when there is a conflict, do something that will keep the beavers in place. You know, there's a lot of different types of conflicts. The most common one we see is beavers plugging up road culverts. And when they plug a culvert up, very quickly, that can become a very serious safety issue. But basically, any place where there's water that beavers inhabit and build dams can create a conflict with human land uses. But I'm happy to say that the vast majority of human beaver conflicts can be resolved by keeping the beavers in place. And so that's what we'll talk about. And one common problem is tree protection. I'm not going to go into that. There's a lot of information online, including the Beaver Institute website, about fencing or painting trees and protecting trees. What we're going to focus on are the flow devices, which help to prevent flooding. And I'm going to cover 4 basic types: starter dams for protecting culverts, pond leveler pipes for freestanding beaver dams, and culvert fences and fence and pipes for also man-made drainage structures. The starter dams are interesting because they're a very simple way to protect infrastructure of a road culvert. You know, beavers see a pipe under a road, and to them that's a dam with a hole in it. And with a little bit of work, they know they can turn the entire road bed into a pond. So that's why I believe that's the most common problem that we run into. But by understanding the beavers, you can adjust that so that the culvert, which initially is the easiest place, if you give them an even easier spot to dam, they'll take that. So that's what these starter dams do, is create a place immediately upstream of the road culvert, so the beaver damming is away from the culvert. For example, here, this 6 foot by 8 foot culvert, box culvert, was constantly being dammed and unplugged by the town. And when we put this in, it immediately stopped their damming of the culvert. And so what we did to do the starter dam, it's pretty simple. You just want to basically start the beginnings of a dam. Now that can be like how a BDA is constructed with wooden posts and woven branches. It could be fencing with fence posts, or even rocks. A rock wall, you know, around here, there's often an abundance of rocks, and anything that will raise the water just an inch or two and create a little turbulence and noise, and the beavers will be attracted to that and start damming on it. And the nice thing is that in addition to being low cost and aesthetic, it's really prevents, there's no man-made fencing or other obstacle that's going to impair wildlife passage or fish passage. So what we build is buried under the beaver dam, and it's just becomes a natural looking thing. So, you know, it's something that highway departments, they can do themselves, and it's the beauty is the simplicity of it. So sometimes though, the beavers may build up that dam too high. So these aren't appropriate everywhere. It depends on what's surrounding the area. But if that dam started to get too high, we could put in a pipe through it, what we call a flexible pond leveler pipe. And the concept here is pretty simple. You put a pipe through a dam, but you protect the inlet end of it so that when the beavers swim by, they can't feel or hear any water going into the pipe. And if they don't sense any flow out at the intake end here, then they'll leave that end alone. And they'll try putting mud and sticks on the dam because they can hear the water escaping, but it won't do them any good because that pipe creates a permanent leak. And when we build it, it looks like this. We'll float it out on these temporary pontoons to bring it out to the deepest area we can, and then sink it like you see here. And the pipe sits on the bottom, and then it comes up in a trench that we dig to the level of the water that we can tolerate. We want to give the beavers as much impoundment as we can while we still protect what we need to protect in the surrounding area. So as you can see, the water kind of pours out when the pond level is higher than the outlet end of the pipe. And then we cover this up with the mud and sticks, fencing, so the beavers can't get at this, and that creates that permanent leak. An example of that was here where the utility found out much too late that the beavers had built a dam over here on the right side, and it was nearly 3 feet of water on their access road. So it was impassable. So we put in a pipe, drew the water level down, and the impassable road then dried out. They regraded it, and months, even years later, you know, it's 10 years later now, and it's been working fine. The other thing with this site that you may not be able to see in the picture, but up here there's a culvert. And when we drew the water down that much, we knew that that would tempt the beavers to plug up that culvert. So we proactively put a fence on it to protect it. And culvert fences work very well. And this Keystone culvert fence is trapezoidal shaped. It was invented by Skip Lyle when he was working up in Maine with the Penobscots. And what it does is it makes what is the road culvert, which is the easiest spot for the beavers to dam, to the hardest. And it does it pretty much in 3 different ways. One is obvious. Instead of a culvert to plug up running under this road, they now have to dam around this entire fence. So that's usually 30, 40 feet in perimeter. So it's a lot more work, and it's easier for them to just go upstream or downstream to dam and leave the culvert alone. Another reason it'll discourage them is beavers will always start damming near the head wall where the sound or the feel of water is the greatest. And the fence, as they dam on it, will force them further and further away from their object of wanting to dam the culvert. So as they move away, that discourages them. And the third reason it works well is when you build it in that trapezoidal shape, when they start damming on it, as they move further and further out, the opening is getting wider and wider. And as that opening gets wider, there's less water coming through the sides of the fence. So the stimulus of that moving water through the fence is decreasing the further they go out away from the culvert. So those three factors combined really make this a very effective, 96% successful, even with the beavers still there. And here's an example one. Here, the beavers already had a dam, which was impounding at least 50 acres of wetland, but they wanted, this is a little area flooded too, and they kept going after these culverts. So we put this fence on, there's a wildlife passage, and they just haven't tried damming on it at all. I hope I'm not jinxing myself, but yeah, it's been working fine. And one interesting thing with beavers is that in general, now they can't say always, but in general, they don't like to bring damming materials out of the water up onto shore and then back down in. So we can put in these passageways to allow snapping turtles and other wildlife to go through the culvert. And beavers will even go through the culvert, but generally they won't bring damming materials. So it's a nice way to minimize impact and roadkill by trying to maintain that passageway under the road. A fourth flow device type I want to review with you is the fence and pipe. And we use this a lot on road culverts. One of the reasons is that we generally only need to check them twice a year. With the culvert fence, you have to keep it clear of debris that floated up against it so that the beavers won't figure it out. Whereas with the fence and pipe, we're allowing the beavers to dam on a fence, so we're making it smaller. And basically, as they dam on the fence, then we have a pipe that we install through the fence, and we set the outlet end of the pipe at whatever height we can tolerate for water so that the road's protected or abutting properties are protected. The limitation of this device, though, is that it has to be a site where we can have that 3 feet of water or so for the intake. If it's shallower than that, the beavers might detect the flow through that caging, and then they would bury that whole end. So with that said, for the right site where you can have some ponding, this is a nice option. And it also is, we're controlling the damming, whereas with the fence, they could dam anywhere upstream or downstream, and then we'd have less control over the water level. So here's what it looks like when we first put it in. Here's another situation where the highway department was constantly cleaning out this culvert. So once after they cleaned it, we put this small fence on there. And sure enough, the beavers immediately started damming on it because they could feel the water going through this small fence. And within a month, it looked like this. They had dammed all around it, and there was no more water going through the fence. And now our pipes were carrying all the water. We needed two 15-inch pipes here in order to manage how much water flows into this area. And so they carry it. And then if there was a huge storm, it would go up and over and through this. Now, we could still do a wildlife passage or fish passage with these. Here's a fence and pipe device, and you can see the well-worn path where the animals are just going up and around. And another, here's one that we put in over 10 years ago. And what's interesting is even with this passageway and all this noise from this water, the beavers have never tried damming in the culvert. They have their dam out here and they've been satisfied. I mean, hopefully I didn't jinx myself, but so far, after 11 years or so, these do hold up to time. If it was a situation where fish passage is necessary, then we can do an adaptation. There's some prototypes of the Snohomish pond leveler where we can adapt the outlet end of the pipe with this box, and that attracts, the fish. Coho salmon have been documented going through these. I like this picture here because they put in 2 of these prototypes up in Washington State, and you can see the beaver and 2 coho that were returning to spawn. So it's we're still need more research and more of these devices out there, but it's showing a lot of promise. So all these flow devices, they don't work everywhere. Irrigation ditches or canals can be a challenge because beavers can dam in multiple places, but for where they are effective, even after 10 years, we have a 95% success rate with these devices. Versus in the blue here, you'll see the success rate, drops pretty dramatically because the habitat's there, and you remove beavers and new beavers are going to move in. So, and then you're right back where you started with with whatever problem you had. So it's really using the flow devices is the most cost-effective and long-term option, and not to mention environmentally friendly. So along those lines, we did a study. The Beaver Institute and I helped do a study in the town of Billerica, Massachusetts that was published. We looked at 20 years of data for the town and the beaver management we were doing for them. And the majority of the sites were flow device sites, but we did have 12 sites where the devices were deemed not to be options. Typically development in the floodplain, there was just no ability for the beavers to dam in those spots. And so we were able to compare, directly, and it showed that there was a lot of cost savings. For each site was $180 cheaper managing with the devices. So it was like $8,000 a year in taxpayers were saving on these 43 sites. Plus, we estimated about 380 new wetland acres that were created by coexisting with these beavers, which, as you can see, just gives millions of dollars in ecological services to the town for free every year. So it's really a no-brainer that whenever possible, we really want to keep beavers in place and let them do what they do. So if you want to download that in the Beaver Institute website in the library section, you can download the PDF, which goes into much more detail about that. And it is a pretty compelling, I think, study that is useful for towns or agencies to look at. So, all right, so we have these devices and they work, but how do I get them? Well, fortunately, we have a new website and we have a ton of information that, including instructional videos to show people how to do them. So if there's no one available near you, that it is possible, but in general, it's better to have someone who knows what they're doing. So we've been training people to do this professionally and over the last couple of years. And currently, those stars are where we have people. And on the Beaver Institute website, you can go and click on find a professional installer, and you'll find these people. Unfortunately, where we don't have people yet, typically Skip Lyle in Vermont's willing to travel to. So no matter where you are, you can get a professional, and we just want to keep adding more and more people to this, what we call the Beaver Corps. So we're ultimately anywhere in the country or Canada, the US or Canada, you can find someone in your region who can do this. Fortunately, the training is all done remotely, which worked out well since it was designed before COVID. And a person can get through it on their own pace, usually, in 6 months to a year, and there's a cost for it. And I'm happy to report that the Animal Welfare Institute just awarded us some money so that we're going to be able to give out some grants to landowners to help financially incentivize people putting in devices by our Beaver Corps people. So we're hoping to build that program so that we can really make a major impact. Right now it's, you know, starting small, but in time, hopefully that grant program will continue to grow. So the last thing I wanted to leave you with is another initiative we're doing, which, as we're hearing about all these great talks about how beavers can help build climate resilience. So with the president's executive order wanting to really address climate change, we want to educate as many policymakers as possible about these benefits of beavers. So on our website, we have a letter that's going to be distributed to as many policymakers as we can think of next in May. And we're looking for organizations that want to sign on and support that letter. So please go to the Beaver Institute website. I'll also post a link in the chat box. So if you want to check that out and go sign our petition and have your organization you know, be a part of this, we'd appreciate it. So with that, you know, I just want to sum up and say these flow devices, when they're done properly, work very well. As you saw the success rates, there is information available through the Beaver Institute website to get professional or self-help. And hopefully you'll, you know, we'll get a lot of people signing on, because the more people we get signing on to the Climate Change Coalition, the more I think we'll get noticed by policymakers. So with that, thank you all very much for hanging in there throughout the day.
All right, Mike, thank you. Super glad to see you getting on the climate change piece and taking advantage of that. So look forward to supporting that. And all right, we're doing good. We're going to have time for questions afterwards, because there's so many good ones and Jackie's catching lots of them. So thank you. But we're going to move right into a local example of Kevin Swift of Swift Water Design. And he's going to talk to us about a bunch of the work he's been doing in California in sort of drilling this down from patterns to details. So without further ado, Mr. Kevin Swift.
All right, thanks, Brock. Can everybody hear me all right? I'm not sure about the
Yep,
my
I
end.
think you're good.
Okay, cool. Let's see about the screen sharing. Everybody see that all right? Okay, cool. I'm a little bit of a what? We're seeing presenter view. Sorry, everybody, just a second. I hate this technical stuff.
Pound post with the best of them, but the old PowerPoint.
Yeah, that's why I do. That's why I'm into low tech process-based restoration. That's the whole point of it.
Power post, not PowerPoint.
Yeah. Okay. Let's try that again. Okay. Brock, don't give me the hook just yet. I promise I'm trying here.
Give you the old beaver tail slap.
There. That look good? Okay. Sweet. Well, thanks everybody that's made it this far. I know we're a little over, so I'm going to try to get through mine in a timely fashion as well. And thanks a ton to everybody that set me up for this. There's been so much great information that's come out that I don't have to carry much of a load here. I'm boots on the ground guy. I'm not a scientist. I'm not an academic. I might be a storyteller. So I'm just going to talk a little bit about how we can restore huge meadows in the Sierras for less than $1 per acre. And I'm going to back into it from coexistence. So be fast paced. You know, it's getting late. Crack open your beverage of choice and relax. Also, big props to all the CDFW folks in the room. Really appreciate the work that you do. So here we go. This fish right here, I know it's a terrible, terrible photo, but this coho salmon got me into restoration. And this fish is the angel on my shoulder in troubled times. So it's only right to include her. Around the time I met this fish, Brock and Kate got me interested in beavers and their positive effects on salmonids. So I went to Massachusetts and learned a little bit about coexistence from Mike, thanks a ton. And then I came back here to California to build a beaver business. I mean, look at how happy I am in that photo, right? That is the smile of total blissful ignorance. You can't see it because I'm wearing a respirator, but I'm not smiling in this photo. When I got back, I did five solid years of tree work. It was dry and miserable. And Mike, you were totally right. Then I finally caught a break from two fish and wildlife maniacs, and you'll meet them in a second. And in June of 2018, I started Swiftwater Design full time. Initially, it was just me, my Tacoma, some hand tools, driving around building beaver habitat and just having a ball. As the projects got bigger and more complex and more interesting, I hired some folks, I bought some more stuff. I also became a boss, which, if you know me, is completely hilarious. Those folks told some friends, I bought more stuff, and now we've built 650 structures on 17.8 stream miles to restore 680 acres of meadow, all of it by hand, using only what you see in this photo right here. But I'm not actually here to gloat about how much fun we're having as a restoration crew. I'm here to talk about how we've dominated the landscape and deranged the hydrology of California. It's caused all these beaver conflicts that Mike's apparently able to solve, but we in California are kind of struggling with. And given our total dependence on unsustainable land use practices, I don't think we're going to fix the source problems of dams, ditches, dikes, levees, undersized culverts, buildings in the floodplains, and et cetera, anytime soon. So that leaves us a few options. We've got push, pull, kill, coexist, and the right answer, but more on that in a minute. Your classic knee-jerk response is to try to push the beavers out by destroying their dams or harassing them. And this is the classic dysfunction spiral I see all the time. Beaver cuts some trees, floods some stuff, human gets mad, tears it out, beaver panics, cuts more trees, rebuilds the dam, human takes it personally. So rinse and repeat until you've turned into Duck Dynasty. Now this is Homo sapiens sapiens, man the wise, getting absolutely schooled by a rodent with 1.5 ounces of brains. Now that makes the human the problem, not the beaver. We know pushing just doesn't work. So your basic FUD is going to have pretty poor impulse control and will eventually throw a tantrum, blow up the beaver dam, shoot everybody. It's like flipping the table when you're losing at Monopoly. Now your tamer suburban dweller type is not going to have the stomach for the job, and they'll hire somebody else, and snap, there goes your beaver. Now that's more like whining to mom when you're losing at Monopoly. Now it's really important to notice right here, I have no moral position. I'm not an animal rights activist, and I fully appreciate and understand all the rationale for lethal control, as well as all of the science that proves it just doesn't work long term. All I'm saying with this gruesome slide is this is a waste of a perfectly good watershed engineer, and your tax dollars paid for this trapping. We could just as easily have invested those tax dollars in rehydrating California instead. And I can show you how in just a second, but let's try some things that actually work. It's not just a cheesy bumper sticker in the Whole Foods parking lot. Coexistence is ecologically sound and morally defensible. So instead of the FUD that's going to blow them up, you get your more ecologically literate people, you get your problem solvers, you get your furry critter squeezers. They're going to want to coexist with the beavers and keep them around. And that's where I come in. So here's some of what I've been doing the last few years. And it's by no means comprehensive. Other folks have built these around the state, and I'm actually missing a couple photos in here. First up was a rancher over in Sonoma Raceway, and she was willing to try a culvert protective fence in spring of 2014. And this thing's working totally fine. The project went really smoothly. Everybody was happy. I enjoyed it. And I got this completely false sense that working with beavers was easy. Now, Mike told me it wasn't, but I thought maybe California was magically different. Well, then in the fall of 2014, I got to install one over in Mordor, I mean Rodeo. This was pretty grim. There was soot all over the place and clinkers in the creek and these huge trucks rumbling by, like right over the top of the pond that the beavers were in. It's amazing what they'll put up with. But in the end, not long after the device went in, the beavers left. That was a little depressing. So, yeah, I hope they found a better spot and made that work. March of 2016, Caltrans wanted one down in Prunedale to protect this really nice new overpass they built that the beavers loved. So during this build, I had these visions of like fat Caltrans checks rolling in, kind of dancing through my head, which totally didn't happen even a little bit. And then no one was willing to pay to maintain this thing. So about, I think it's been 4 years now that debris has been washing in on top of this thing. You can't see any of it. The dam, none of it. It's all hidden. And it was flowing just fine. I haven't checked it. Well, I didn't check it at all last year. So who knows? Next up, Creekside Greens in El Dorado Hills, April of 2018. The two guys on the left in this photo are the maniacs I was referring to. They're the reason I'm now building beaver habitat all over California and the West, Nevada, Idaho. Nothing in Oregon yet, but we're hopeful. So this is a big shout out to Damian Ciotti and Jared McKee of US Fish and Wildlife. They gave me my first shot at restoration. This project was great and restored my sense of hope. So by now you're sensing a pattern here. Tulakay Creek in Napa, they got one to help build out a bank stabilization project over here. I don't know if you can see the cursor, but that excavator is working on a hotel pad and they wanted to stabilize the bank. So we used the pond leveler to drop the water a little bit so they could see what they're doing. That worked perfectly until a huge storm pulse blew out the dam entirely. At the moment, that leveler that you see on your right is hiding in the bushes waiting for the beavers to rebuild. Further destroying my hope of becoming the Mike Callahan of California, this project was first described as a wonderful interaction of human and nature and then decried as an atrocity, all within about 24 hours. So, sometimes it's hard to know which way this is going to go. And over the last year, we've gotten 4 pond levelers installed on Friar Creek in Sonoma. Things swung back over to easy mode here. The real challenge on this one was actually getting anything done and not dying of laryngitis, because every single person that walked by wanted to talk about beavers and how excited they were. These folks really love their beavers. And Sonoma Water, too, has just been an absolute joy to work with. This is one of the crew with her work face on. You can see we're clearly suffering. These 4 devices now support maybe 1.25 acres of beaver habitat right in the middle of Sonoma town. This is where we're going to pivot from coexistence to active restoration, because these beavers that you're looking at, they're never going to gain any freedom space. They're never going to have any room. And look at the map. There's nowhere for them to go. So clearly beavers are heroes, but Batman had Robin. All heroes need help sometime, and that's where we come in. So this is the pole model. And a couple of quick notes. As I said, I'm not a scientist, so I'm going to frame the problem of restoration, pace, and scale in financial terms. Just because it's math, I can do with a crayon. Carbon burn per acre restored, I think, is a better metric, but I'm not done with that. So also, obviously a flood channel in downtown Sonoma is not a meadow in the Sierras, but pace and scale needs to include all landscapes. And lastly, I'm only talking about habitat quantity, not quality. That's been well quantified by a lot of other folks. They're scientists. They'll do a much better job than I could. So trigger warning, a couple of ugly number slides incoming. Here's the first of them. I know it's terrible, but stick with me here. UC Davis Meadow Clearinghouse covers 112,000 acres. If you've seen those polygons, it's pretty low, but it'll illustrate the point just fine. Friar Creek has 1.25 acres of beaver habitat. That cost $3,600 an acre to restore, which restored 0.000011% of the acreage in the Meadows Clearinghouse. So at that price, it'd run about $400 million to fix those meadows. And that's about 3 1/3 of the new F-35 Joint Strike jet fighters that don't fly. So we're going to have to move some zeros around if we want to get ahead of climate change and actually do proper scaled restoration. Here's the thing, you only need a pond leveler for human conflicts where the beaver's potential is going to remain limited forever. So what if we built beaver habitat instead? These numbers are the lengths of floodplain dams out at Doty Ravine. You can see my van down here, long wheelbase Sprinter for scale. And these dams are really worth seeing. It's really impressive. So, bug Damien and I for a tour at some point. Here we go. Doty Ravine in 50 seconds. The video has no sound. So pace, scale, that's pretty good pace there. Let's talk about scale. Currently, Doty Ravine, in my opinion, is the most fully realized PBR project in California, which is process combined with beavers, I think, is the most effective way. That's 65 acres of pure beaver paradise built for $1,076 an acre. And that's pretty cool. We've clipped a 0 off the percentage of our meadows, but it's still 3 zeros. And restoring the Sierra Meadows at that price would cost $120 million, or roughly 11% of the cost of repairing the Orville Dam debacle that almost killed who knows how many people. But we've still got to make it cheaper. If we're facing a huge problem, our dreams and our visions are going to have to scale to equal that problem. Otherwise, we're stuck thinking too small. And this was my first attempt at dreaming bigger. It's a piece of my build at Shen Ranch. It's up in the headwaters of Smoke Creek, and it's your standard California habitat. Dry, incised, overgrazed, beat up, single thread channel. But we didn't have to deal with any levees. There's no infrastructure conflict. If we got beavers in there, they could build 2-story dams and absolutely no one would care. And this is what it looked like 6 months into the build. Project total is about 500 acres. And in there, we more than doubled both the stream miles and the wet meadow area for about $250 an acre. We need another 100K to really buff it out. At that point, we'd be 850% cost improvement over Friar Creek, 60% better than Doty. So now we're down to $50 million. We could build all of the Sierra Meadows for $50 million. Now we got trillions of new dollars sloshing around in our pork barrel with all of this stimulus. I guarantee somebody's got that under their couch cushions. I mean, come on, that's less than the cost of recovering Big Bertha when she got stuck boring underneath Seattle because she ate a pipe. This is a tiny number. We could almost crowdfund it, but it's still 50 million. All right, can we do better? Let's keep dreaming bigger. This is my messy as-built for Tasman. Each of those little dots is a structure, 2,300 acres. Last year, we got 2.9 miles of stream built, affecting 180 acres of the meadow for 70 grand. If we didn't wait for process, that'd run 600K, but we don't need to build all of this with just human will and persistence. Tasman's got a 1,270-year-old beaver dam in it that Kate's going to talk about on Friday. It's super exciting, very, very cool news. They were still dynamiting beaver dams in here up into the 80s. There was a sighting in 2017, and we know for sure they're living down the main stem at a tribal member's mining claim. Now, Brad and Kate aren't quite sure that they're going to make the trek. I got $50 says they're going to be there in a couple years because the habitat is just, it's just so good. Brock would hate my PowerPoint without a scenic shots. Here's one. It's pond at Shen Ranch. Give everybody a break. So far, we've covered push, pull, coexist, and pull. And we've carved $350 million off a restoration cost. We're not done yet. There's one last thing we've got to talk about, and that's courage. The root of the word courage is cor, the Latin word for heart. And in one of its earliest forms, the word courage meant to speak one's mind by telling all one's heart. Every day, we face the same test, whether we're going to be courageous or pursue our own selfish ends. Every time we're courageous and pass that test, we grow as people. Every time we fail, a little hope for the world dies. And the best friends we're ever going to have are those that will say the hard things to us, not just support who and how we are, but actually help us grow. So as a friend, I have to tell you folks on the CDFW side of things, Fish and Game Commission right now is on the wrong side of history here. I know it's not your fault. I get it. These are benighted ancient regulations that nobody alive now had anything to do with. I get it. But you cannot simultaneously work for endangered species and kill thousands of the beavers that support them every single year. It's organizational schizophrenia. And the pace and scale of restoration is way too slow. Climate change is orders of magnitude ahead of us right now. If we're going to speed this up, we have absolutely got to change the regulatory environment that makes it painfully slow to get anything done. So here's a pirate flag for courage, because beaver reintroduction seems scary. I get it. Everybody's worried about it, but it's not actually that hard. A lot of other states have succeeded. Very robust templates exist. And all that's lacking in California right now is institutional willingness to change. So please, somebody on the inside, Step up and be a hero. Help us legalize reintroduction of beavers in California. Because as soon as you do, we can move problem beavers like the ones in Friar Creek up to places like Tasman that have thousands of acres of habitat, willing landowners, proven historical and recent presence, and no urban sprawl choking the creek. So 2 nights of trapping, 2 tanks of gas, 2 weeks of quarantine at Sonoma Wildlife Rescue. And we can get those beavers to Tasman for $1,500, and they'll restore it for 65 cents an acre. By just relocating beavers, we could restore 100,000 Sierra Meadow acres for the cost of Doty Ravine alone. And these are actual numbers based off 18 builds that I've done and the real cost to trap and move beavers. Sure, the error bars on this are big. I'm not a scientist. I'll freely admit that. But come on, hell, if I'm off by 2 full orders of magnitude, you're down to $7 million. And that I know you can crowdfund. They do that for mobile gaming apps. So if we're really serious, if we really mean to restore our desiccated landscape in anything like a timely, cost-effective manner, commensurate to the disaster that approaches, we've got to make reintroduction legal. And if we're not serious about it, then we should just quit our jobs and go do something that allows braver people to take our places. So that's pretty much it for me. I want to thank everybody for listening, for caring enough to be here, and for all the good work that you do and have done. We've got a huge job ahead of us. And we're only going to succeed if we can work together and just make it easier for everybody. And I've got one last tiny piece. I will personally pay $1,000 cash, no questions asked, to anyone who can bring me the full transcript of the case where CDFW lost a lawsuit for having relocated beavers. Frankly, I don't believe it exists. And if I'm wrong, it's even better. I would love to pay $1,000 to someone to find out why CDFW lost this lawsuit, because then we can start figuring out how to protect you CDFW folks from future liability. We, the beaver community, will take that on and make that happen. So $1,000 to the first person that get it to me. That's it. Thanks, everybody.
Wow. Woohoo. There you go. Geez, we got the webinar cost is free and you have a chance to make $1,000. That's I'm loving that. All righty. Well, this is great. Thank you, Kevin. Courage and passion. Get after it. I think at this point we're good to go. We've I want to offer a couple a couple things just to let people know, so that if folks take off and to join us Friday, you can do that. And then we're going to open it up to the whole group of panelists who've spoken for Q&A. And Jackie's got some questions she's queuing up from those that you've submitted. But I just did want to mention that for the gluttons in the room, if you want, actually in Tucson tonight at 6 o'clock, the Watershed Management Group is having a virtual beaver seminar tonight. So you could just keep going for more hours if you really need to. Just go to Watershed Management Group's Beavers and Brews Binational Bash event. There's a fundraiser for beavers in the Sonoran side of Mexico and in Arizona. And I know that the folks at Beaver Trust, they've been having a whole big fat beaver quiz today for the international piece. And then also tomorrow night, go to thebeaverbelievers.com and that virtual screenings tab. And Sarah Koenigsberg and Dr. Emily Fairfax are doing a showing of her film, Sarah's film, The Beaver Believers, and also they're talking as well after as a virtual online piece. So lots and lots to go here. And with that, I want to open it up. I think the other panelists can unmute themselves, maybe Jackie, you want to as well, and if you want to ask the questions, Jackie, or I'm happy to do so, depending on how you want. Shall I just go for this?
Yeah, if you can see it here, go for it, Brock, and I'll keep queuing them up.
Okay, great. All right, first one that's queued up is for Michael. How do fish navigate a beaver dam if flow diversion dams upstream prevent flushing flows, which would, under unimpaired flow regimes, be possibly breached naturally? Mr. Pollack, what do you say? Still got Michael on the horn here.
See his icon, but maybe he's not at the computer. So maybe we can go to the next question.
Anyone else want to take that? I mean, I think it's an interesting piece around fish and unimpaired flow regimes. And some beaver dams don't breach in certain flow regimes. And in what we see in the coastal zones with flashy systems is portions breach and fish move past, and the beaver rebuild them during the dry season and impound water for rearing of habitat. And so the breaching and not the dynamism, the stochasticity of beavers in these systems is the essence of that adaptable, responsive, resilient nature that Karen was talking about. Anybody else
This
want
is
to take?
Margie from Fish and Game or Fish and Wildlife. I guess I would say that that fish often leap over beaver dams, and just because it fills with sediment doesn't mean that the side channels that it might have created have filled in. So fish often will pass by swimming up side channels that have formed around beaver dams. So there are still ways for fish to get past in a lot of cases.
Yeah, I think we've had enough studies at this point. We're going to hear more from the Scott River folks tomorrow about the passage issues as well. All right.
Rob, could I just add something to that?
Sure. Yeah, Jeff.
So I think it's important to remember that these two species have been living together in the same areas for literally hundreds of thousands of years. And so they are co-adapted. And so as our friends in Oregon like to say, beaver taught salmon how to jump. So they are co-adapted. They are used to living with each other. In fact, salmon find value in what beaver do.
Yeah. All righty, Kevin. How do specific goals, objectives, monitoring, and adaptive management, which is the science of ecological restoration, fit into the ideas in your presentation?
A great question. And again, I'm not a scientist, not an academic. I'm boots on the ground, shovel in hand. My version of monitoring is just to go look at the site at different flow conditions and adaptively manage. So, if I see, Marjorie, like you were talking about, you don't necessarily have to fix or change every structure that evolves over time. That's kind of what we're looking for is that dynamism. I think in terms of restoration goals, we need to be quite clear about not falling into the form-based construction boxes of you're not going to get 3 decimal places of accuracy out of a crazy, messy beaver swamp. You just can't do it. So I think until we're able to more coherently discuss the large-scale effects of beaver habitat complexity, we're not actually going to be moving the dial. Damien's got a whole bunch of really great work out. They're working on a paper talking about restoration metrics, what it actually means to have a site that's improving. So I would say I'm more messy like a beaver than I am a scientist. And at the moment, I don't have any monitoring money. I don't have anything on the backside of these projects. It's just me and my drone. So if somebody wants to jump in on that, oh my God, it'd be fantastic. I'd love it. Yeah.
All right. And a lot of times I know you're working in partnership with other folks, and like some of the projects at Tasman are in collaboration with the tribes and MSC and the Forest Service and Damien and others who are monitoring. So that's key. All right, Mr. Callahan, did the beaver remain at the site with the access road that you showed? And what happens to the beaver after installations in the long term?
Yeah, that's a good question. The beavers were there. We knew they were there about 6 months after we put them in the device, and they've been pretty much there the whole time. It's a spot where there is a lot of cattails and water lilies, and they can, even if the woody vegetation gets depleted, they can live on those in our winters, eating the tubers. So yeah, beavers have been pretty much there the whole time.
Nice. All righty. Okay, Marjorie. Some folks want to know how you can change CDF policy to allow translocations of beaver in the Sierra Nevada.
Well, it's probably not going to be me, but I would say that you know, digging up that lawsuit and finding out more about it. I would say that lobbying your state legislator to put pressure on the department or change the law. We have we've got a lot of more grassroots efforts, sort of changing the ways the department does things through the Cutting the Green Tape and through, we have a Restoration Leaders Committee that's formed of a lot of the larger, not even larger, but a lot of the major players in restoration in the state. And they seem to have the ear of the director. So, I think organizing yourself into groups and lobbying the right people higher up the food chain is probably the best way to get that get the changes made. I have to say, as they should be, our legal department can be pretty conservative, and so the staff in the department really doesn't have a lot of say in how the code is written. So it's probably not going to come from the bottom up within the department, but it's probably going to come from the outside in, honestly.
Right. Yeah. Thanks for that. And I know we have Kate Lundquist speaking tomorrow, and Kate and I through OAC have been active in this engagement with a number of other folks in the state around current existing policy and opportunities to be that democratic force to offer from the outside. Yes. So we'll hear from Kate more on that tomorrow for sure, yeah. All right, Karen, how do beaver dams and analogs benefit Western pond turtle? And also, what will be the impacts of beaver dams on riffle species?
The Western pond turtle question, I actually don't have any data on that, but I can't see how they would hurt. My guess is we're going to start seeing pond turtles, using habitats behind BDAs and beaver dams. Brock, do you know of?
I just have my anecdotal observations of a number of beaver dam locations, and that flow that we see pond turtles, not infrequently there, and often more frequently that's the only place I do see them in some of these systems for sure. So
yeah, I think it's anecdotal. It's amazing how little research there is in California on beaver and amphibians and reptiles, and I think part of that is that it just wasn't on a radar with the whole nuisance species in California concept. So I'm guessing there's going to be a lot of research on this topic, and we're going to see all the benefits and coexistence. And then the riffle species, beaver do a great job of actually increasing riffle, because they often put dams and then there's a section of flow, and then dams and a section of flow. And so my guess is that they would be beneficial even for riffle species. In a lot of our degree, it's a rare thing in California that you find a system that's completely intact. And so most of our channels are single thread. And when beaver work in the system, then downstream is often still that somewhat incised single thread channel. And so you get these periods of dam and channel. And so we get just incredible diversity of aquatic species within those.
Yeah, the heterogeneity of the complex, that's the beauty of the beaver messiness. A chaotic process, there's chaos and order and a harmonic balance. And I am, Jackie, want to remind people, so we have part 2 of this on Friday, and we're going to have 9 other amazing speakers like the 9 today, and we're going to address a bunch of questions like that. So when I mentioned that Kate Lundquist will be talking about this and others, that's on the Friday from 1 to 5. So Trina, got a question for you, which is, what are the regulations around beaver reintroduction for your work on sovereign indigenous lands?
Well, it's, our lands aren't sovereign, and we are an organization comprised of multiple tribal organizations and organized as a 501c3. And so we have to abide by the same state laws as everybody else. There's some individual family allotments in Plumas County where we're at, and there is one federally recognized tribe that's pretty much landless, has maybe an acre or two, and so we have to abide by the same as everybody else, and so that reinforces how important partnerships are.
Yeah. Again, not that I'm going to keep punting stuff to Kate's talk. I'm filling up for 20 minutes, but she'll probably mention some work we're recently been doing with another tribe in California that's in a stasis at the moment, but they are a federally recognized tribe, and was related to their federally recognized land, which is unfortunately different than Tasman Koyom. So
yeah, in Tasman Koyom, it was part of the PG&E divestiture process, so it had to meet public benefit, and there's conservation easements, and there's all kinds of things that we can't do on it, no matter how much we want to. And so even restoration activities, because of the conservation easements, have to meet certain guidelines. So it's kind of frustrating, but it's where we are.
yeah. All righty. All right, Jeff, you're up here. Some studies indicate beaver activity promotes methane production, which accounts for about 15% of wild animal methane production. Would the sequestration of carbon in the soils outweigh the production of methane released from beaver ponds and dams?
Yeah, so I saw that question earlier, so I did a little calculation. So from a beaver pond per hectare each year, we're going to get about 2 to 4 kilograms of methane per year. Pond fills in about 10 to 20 years, so you're looking at maybe 100 grams of methane emission per hectare. And what we find in wet meadows, or formerly wet meadows in Sierra, is per hectare we are storing over 20,000 kilograms. So 200 kilograms worth of methane versus 20,000 kilograms worth of carbon. So yeah, there's carbon in the form of methane, but compared to the amount of carbon that gets locked up in those soils forming at the bottom of the ponds, it doesn't seem very large.
Yeah. It appears in the big picture of methane releases with fracking wells blowing up around there, that blaming the victim beaver on the methane piece might.
No.
But that's me opining. I guess I should stick to my formal role here and go to Rick. For those outside of California, Rick, how would you investigate historical or local regional beaver populations?
Well, my interest is mostly in the historical. It's a lot easier in other states that were U.S. territories earlier and established museums earlier than it is in California. But I think a couple range maps were shown early. Beaver were everywhere, from desert streams and rivers to continental divides. They found beaver remains in the Rockies. I think we should assume beaver were everywhere, from northern Mexico to the tundra line. And if someone says, well, is there a little more evidence that they were here? I would flip the question and say, why even asking? Well, why wouldn't they be there is the real question people, I think, should be, because it's the evidence is now just so massive.
Yeah, flip the question. I don't know if do we have Ben on the line still, or I'll toss this question out. I think probably others can take this one on if he's not here. How does ecological restoration with beavers go hand in hand with other land management methods? Anyone else want to take a crack at that one?
I think Jay Wilds
was
The
busily
wild
typing.
prevention video does a nice job covering that.
All right, go ahead, Kevin.
Oh, I was just going to say I was busy typing the chat. Can you bounce the question off me again? Sorry.
Well, I think we're just they're interested in how does ecological restoration with beaver go hand in hand with other land management methods? Kind of a
Oh,
broad.
sure. Yeah, there's a really good nexus there. You know, like grazing management is one of the primary issues that we've got to confront if we're attempting to do, you know, if we're going to do a BDA build, we've got to get the cattle managed because they'll punch holes in the structures and cause us trouble there. That said, if you can get your site restored and then do flash grazing with the cattle, you get really good carbon sequestration numbers out of those kind of combined restoration practices. So that's one that I've definitely had direct experience with, and I'll leave everything else to the rest of the folks.
Yeah, I think that, and I know Bethany just chatted that, and on Friday, again, we're trying to get you to come back on Friday. She'll be speaking about the relationship of beavers and the forest management work that they do. And so beavers in forest land settings is one piece, beavers in rangeland settings is a piece, beavers in intensive agriculture settings is a piece, beavers in urban areas. So the associated land uses around the fluvial habitat that beavers inhabit and the adjacency issues, there's a portfolio of relationships there to find an equilibrium and a balance. And we got plenty of tools in the toolbox to coexist with them. So it's really just supporting the ecosystem restoration capacity of these organisms starts with the restoration of the ecosystem, which is what we're doing here in the next these 2 days, is restoring your ecosystem to engage the beaver believers. So, all right, I don't know if Michael Pollock has joined back on here or not, but maybe that's somebody else. Oh, there you are. Michael, has anybody compared evaporation from human engineered versus beaver engineered dams? And I assume they mean the ponds behind the dams with respect to the surface water. Evaporate?
I haven't, but there was an interesting study I just ran where they looked at evapotranspiration from reservoirs and other things. But a direct comparison, no.
All right. You know, one question's in there about, and it comes up a lot, and there's the question of water rights. And if a beaver is damming up an area and holding back water, and the downstream water users have a set of water rights, are those beavers stealing their water rights? Is that a protected use? Anybody want to take a crack at water rights and beavers? You know, the old whiskeys for drinking and waters for fighting over, Mark Twain quote for California water politics in the 1870s, by the way, is still around. So, Michael, you want to take a crack at water rights and beavers?
Sure. A couple of interesting cases that didn't ever make it into law. They were kind of at a lower level. There were arguments made along those lines that the beaver were stealing water, and they weren't held to be valid. There was one in Idaho and then one here in Washington. So there hasn't been a case law that has shown that where they've determined that beaver are stealing water, so to speak, and then dams need to be removed. But there was a case, and I have to go dig it up. I want to say it was in the Sierra, maybe on the Nevada side, where the downstream landowners had a right to clear the trenches or the diversion ditches that were coming off of public land, so they could clear them of willow and things like that to ensure that the water came to them. So it wasn't about stealing it per se, but it did give that. It was written into the agreement that they had the right to do certain things to ensure conveyance of water. But that wasn't a water right issue. It was just simply access to an existing water right.
Yeah,
Jeff, do you want to weigh in on that one at all, or you familiar with that?
It was either in the Walker or the Carson drainage and the Nevada side ranchers down in the lowlands about beavers. Certainly in the Carson, there's been a lot of issue around ranchers coming up from the valley in Hope Valley to take out beaver dams because of the perception of the, maybe not the quote stealing of the water, but the influencing of the timing and the delivery. And this is an area where, and I think the work that Rick spoke about that we've all been involved with about establishing, affirming the nativeness of beaver in an area is a bit of an issue, because the water board in one of those cases over there accepted the idea that beaver were native to that system, and therefore they're a natural part of that ecosystem, and therefore their relationship to whatever's happening with the water flow is part of the natural water flow, and it can't be misconstrued as an impoundment that needs to be removed. That is an infringement on anybody's water right per se. So this is a really ripe area. I'm sure there'll be, with the drought, well, there'll be more case law and fighting over this. So,
Hey, Brock, I just want to add that there's just no evidence to support that idea, which is, you know, you got to use the best available science, and that's been sort of the weakness of the arguments. You know, there might be some situation where someone could demonstrate that that was the case, but it just isn't really. I just haven't seen any evidence to suggest that, and the historical evidence generally suggests that when you get rid of beaver, you lose water, not gain it. So, and then the last one, I testified in a case up here where they said, well, we have a right to that water stored behind the dams, and I said, okay, fine, let's just assume you do. Let's just figure out how much water that is in terms of increasing stream flows, because they wanted to divert water, and they were saying the beaver are holding up all this water, so let's release the water and it'll improve stream flows. Well, we did the calculations, and it was going to provide about a 10% increase in stream flow for about 24 hours. And that was the whole volume. So that the hearing, it was a hearings board, that pretty much ended the case right there, you know, but again, it's just that perception thing that there's somehow this vast amount of water that's being stored behind these reservoirs. So.
all right, and I'm seeing Emily is saying that she'll be on her keynote again on Friday. Be there at the beginning. That she'll talk about some studies she has done around the relationship of evaporation and evapotranspiration associated with plants. So that'll be fun to hear Emily's thoughts and work on that. Let's see, anybody, I'm still looking at a bunch of questions, but if any of you, if something another panelist brought up or you want to augment or expand on while we're here, we are at our 5 o'clock moment. And so technically we could just call this quits, and then those folks who just have to stay on and keep chatting, we can kind of do that. And maybe that's my responsible thing to do right now, is say it is 5 o'clock. You all have been here since from 1 to 4. Thank you, thank you. There's still 245 of you on. We were north of 500 for a while there. So how about we formally invite you to come back and see us on Friday. Same Beaver channel, more or less. Click on that proper link. 1 to 5 again. 9 more great speakers. And anybody else who would like to stay on and keep sending us questions through the chat and the Q&A. Those of us who stay on will stay on. And otherwise, have a great rest of your Wednesday evening. All right. Lots of love coming through the chat. You're coming in. All right. Somebody wants to hear from Kate on Friday. Well, anybody else? Heidi, you want to come back on, and what do you think?
I was just going to say that this is Heidi, that if I'm a landowner and my well goes dry and the resource says that beavers recharge the aquifer and my neighbor has killed beavers, can I sue him?
Oh boy.
I mean, it works on both ways, doesn't it?
Yeah, I think there's that classic answer, it depends. Your capacity to have a causal correlation to the relationship of the death of beaver and your well going dry as a direct linkage in underflow fluvial groundwater spaces. Yikes.
Yeah.
Hey, Brock, if I could just weigh in, you of course can sue them. Absolutely.
Will you win or not?
Is do you have a big case? And you know, if you have the money, I think it would be really interesting to see what the court said about it, because you know, I'd love to see the argument put forward that you are. I mean, we've had the same discussion, policy discussions about, is it a take case if you take out beaver, is that a taking because you're for ESA listed coho salmon? So no, that's never been litigated, but you know, sometimes when you can't come to resolution with science, sometimes the courts are actually a pretty good place to get some resolution. It's just scientists are a lot cheaper. That's all.
Especially after midnight. You know, I think your point, Michael, in the very beginning was in the comparison is that if we're concerned about wells going dry and groundwater tables dropping, boy, the humans, we've done a really good job at that, which at least for those Californians who are still on here, we were the last state, Texas a little bit there, to finally get a groundwater management act. And we got the Sustainable Groundwater Management Act in 2014, SGMA, and the creation of all of these groundwater plans and these groundwater sustainability agencies to deal with the crisis in every basin, in every groundwater system in the state, where we're declining groundwater tables, we're way beyond sustainability, and we're talking water depths that are way beyond the reach of beaver influence. And so we have such a crisis of dry wells. And as old Ben Franklin said, you never know the worth of water until the well is dry. And so to the degree that beaver can show up in these areas where the creek corridor is connected via the geology to the groundwater table in question, which is a really different, you know, the geology matters, and it's really diverse in California as the nightmare of rocks, according to many geologists. But boy, in some places it sure does. And it's pretty indisputable they're connected in that realm. But so I don't know, Heidi. Yeah, maybe you can bring on the test case.
I think Michael's calculation that it would provide such a little amount of water for such a short period of time, when you compare that to how much it stores in the groundwater, the shallow groundwater, and adds to the base flow and continues the base flow into the drier months. You know, the water users are really shooting themselves in the foot for wanting to take that beaver dam out and drain all that water right away, when you can really, you know, provide such a longer duration of base flows by keeping the beaver dams in. You know, I think that just gets lost on them. They don't really understand. So
I think that's a really good point. And I would just say that that's one of the things they discussed in the New Mexico summit. They talked about how important it was to educate the various landholders about the fact that by holding some water in a beaver dam, you were actually saving it over time in the groundwater, and that allowing even for some documentation of that really helped landowners sacrifice a little bit.
So one of the interesting things I would offer here is that with respect to the agencies as well, CDFW has their water rights division. The the agencies that are missing here right now are both the California State Water Resources Control Board and the Department of Water Resources, who deal with both water quality under the Federal Clean Water Act or the Port of Cologne Act, and the Department of Water rights and the water quantity and quality game. And Kate and I, with a number of folks, were hosting a convening up north last year, pre-COVID actually, it was 2019, around the translocation, relocation questions. And we had a regional water quality control board person attending. And that person was interesting in his thought about, maybe we at the regional board, based on all of the science and studies showing the benefits of beavers protecting water quality and the beaver wetlands reducing nitrogen and phosphorus and a number of these pollutants in many of these nutrient-laden systems where there's TMDLs, they're 303D listed as impaired water bodies, that actually the state board or regional boards ought to step in and begin a regulatory relationship or list beaver as a beneficial use on behalf of protecting water quality and or water quantity. And that's a whole arena that some of us are pushing on to see if we can't get these other state agencies to jump into the conversation on that. Could be very fun. Anybody else? And I don't know if people are tracking the Q&A, if we're getting.
Brock, I saw there was a question about using BDAs where beaver aren't going to colonize. And the concerns over that or the successes over that.
Yeah, who wants to step up to the beaverless BDA conversation?
Oh, I like it. So this one is, I'm not going to say it's a bone of contention. It's a great conversation starter with anybody in the restoration beaver community nexus. You know, the one way to look at it is you don't need beavers. You can just do this as a human and improve habitat. But the reality is you don't need beavers if you are just looking for like kind of a one and done. You want to claim victory for having thrown some wood in the creek. That's great. But to really get the long-term trajectory for large scale landscape areas, you can do a lot of great work with beaver dam analogs. Human restoration can be completely amazing, but we're not going to be on site 24/7. Yes, we make more of ourselves all the time, but none of those selves that we make are out there working either. So beavers replicate themselves on site, grow more of their own food so they can grow more of themselves, and et cetera. So you get this really amazing virtuous spiral where the beavers make habitat that they can then live in so that their population grows. And you don't have to monitor that. You don't have to pay for it. You never have to file a permit. So if I could only do one style of restoration, it would always have beavers involved, but our population is so small. Well, I mean, nobody even knows how big it is, right? But it's a really small population. So if we want to move them up where they can do the most good at the moment, we've got to build them somewhere to go. So there's no point in trapping beaver and dropping it off in some incised stream. It's just going to get eaten. So I think our responsibility is to give them the foothold, that first ladder up into areas where they can do some good. And if they aren't there, then we need to step up and replace those keystone species that we've destroyed. I think that's just our responsibility. That's all I got on that.
I would say that the department, when we were writing our restoration chapter on BDAs or on low-tech process-based restoration, we wrestled with this this topic a lot. I would say that in our last iteration of the chapter, we said that, you know, we only considered BDAs to be successful if they were colonized by beaver, and that's not the case with our new draft. And you know, definitely it's cheaper and more effective to have beaver, but we do think that with enough volunteers and with enough project oversight on the grantees perspective is that you can do enough to reset the channel to have benefits. But those benefits, they could only be realized for 10 years. But then again, if you chop and drop a redwood into the creek, you might only get 10 years out of that too. So we've taken the stance that they don't have to be colonized by beavers in order to be considered successful. But it's definitely a preferable thing if they are.
I'll just say that's great to hear. And I totally think it is important to look at BDAs. I mean, so if our alternative is pond and plug, and we say, well, beaver are in the system, so let's use all other restoration techniques that aren't beaver based, and we move to form based or construction based restoration, that to me is a hard sell. And we're starting a big research project where we're looking at putting in BDAs. We're not looking at where beaver are, but we're looking at where catchment disturbance is, with the idea that it's not just about water and water storage, but it's also about sediment capture. And so if we can partner, California is burning up every summer, so if we can partner these BDAs with sediment, known sediment pulses, fill inside stream channels above the dams, then we are making progress. So I would argue that yes, beaver in the system is the gold standard, but it doesn't sell. Don't sell off the BDA approach because we don't have beaver in the system.
And I would just, step in here. Those of us who are in the coastal zones of Marin, Sonoma, Mendocino, Humboldt counties, who've been involved in the salmonid restoration work for a couple decades, and the large woody debris jams and the root wads and the channel spanning structures. And there's a whole litany of kinds of structures that the restoration community has creatively developed out there for increasing roughness and complexity in channels, some of which span channels, some of which don't. And so we often speak with a number of folks that BDA is a type of a structure, and it has pros and cons, and it's like anything else, the tool in the toolbox, and just engaging us. And so there's obviously a lot of salmonid habitat restoration work going on in the coastal zone in beaverless places. We're going to hear about the Klamath, where there are beavers up there, and they're working. When you compare beavers up with the salmon restoration, woo boy, the bang for the beaver buck and the salmon return, the ROI on the salmon return is really amplified. But I did see one question that somebody asked about, where are some best places in the Bay Area to go and see some beaver activity? And I think Napa, the downtown Napa Creek. And I'm not sure, Marjorie, that's what's behind you in the picture?
Yeah, it is. I worked on the Napa Creek project, well over a decade ago. And I would say the best outcome of it, besides maybe the humans enjoying greater flood protection, is seeing that the beavers have taken over both flow split sites on Napa Creek. And so it's so cool to go out there and see them working in an urban environment and actually not messing anything up, because there's a flow relief right there. So it's pretty cool.
Yeah, that's definitely our
We have some active beavers in Fairfield. We have on Laurel Creek, there are 9 dams right now being maintained, and we have a lot of people really interested in them.
Great. How's the Martinez beavers, Heidi? Are they viewable these days, or are they moved upstream?
That's now had a dam that was built behind the park where the Beaver Festival was held, and it had crutches in it and alcohol bottles, and the city someone ripped it out. So we're in between beavers right now.
But no prosthetic legs this time.
No legs, apparently. Maybe that's why they didn't stay.
Because those dams, when you had them, those were legacy dams, because you could see the legs in them. That's why we call them a legacy dam, right? Hey.
Why?
Why not?
Heidi, there there was a question, and I thought you might want to take it on. Someone was asking about how can they find out about depredation permits in the Tahoe Basin? If you had any recommendations about, for anyone.
To find out about depredation permits is
Uh-huh.
to do a public records ask to the Department of Fish and Game, and they have this whole formal way you have to do that through a lawyer. And but I can tell you what has been happening, because we've done those records requests for the last 13 years. So we can tell you what's happened over the years in the Tahoe area if you contact me at martinezbeavers.org.
All righty. Well, what else? What else?
To jump in for a second, with you specifically, Marjorie, I'm really excited to hear that you're rewriting it to say that beaver is colonizing, it's not needed for success. I think it's a super important point to make. Success is vegetation, it's wider floodplain, it's engagement with fluvial power that drives process. And success is one of the metrics Damien's working on that paper as well. It's like, you know, what do we call success in these projects where maybe your structures open up, maybe they evolve and they end cut, but over a decade you do grow that depositional zone and you start seeing the riparian vegetation spreading. I think that's really a good success metric that doesn't require beavers. I mean, I can't remember, Michael, was it you that did the talk on where we start seeing streams go from entirely geologically controlled to then plants show up and then beavers? There's a really cool bunch of work done on that sequence. So yeah, thanks for that.
All right. What else? What else? Anybody else got things? I mean, the Q&A from the audience we're kind of covered that, but I see there's 125 people still listening. There 124. So if folks listening have a specific question you want us to get at, you could put it into the Q&A or the chat here.
Brock, what do you think about letting people do the raise hand feature and ask their questions at this point?
Sure, yeah, and yeah.
So if you have a question and you want to ask, feel free to raise your hand and we can unmute you.
And I see that Muriel wants to know about levees versus beavers and conflicts. Anybody want to levy an opinion on that idea? Ooh, I breached one, didn't I? I had to breach it. Come on, Beaver.
Well, I think there's an interesting combo there, you know, between nutria and beavers punching holes in levees. There's a lot of kind of black swans hiding in there where you might see cascading levee failures and salination of farmland in California and whatnot. So that's one that we should try to solve.
Last.
I'm trying to remember where it was, but they're working on looking at just laying back the banks, because eventually if the banks are low enough angle, the beavers have to burrow a long darn ways to build a lodge, and they don't seem to favor the much lower angle banks. But when you're talking about modifying how many zillion miles of California's infrastructure, I don't know how we're going to solve that one. So, you know, we need somebody like Mike out here that's just inventing like crazy to get on that one.
All right, Keith, I freed you up.
We wait for like Amsterdam and stuff like that to figure it out, because they are working on the same things. There's a lot of raised levee structure in Europe that has to deal with beaver habitat. So once they figure it out, they'll let us know.
All right, Keith, you've got a hand up, and
Yeah. Actually, I was just going to give a clapping hand, and I just sent a text. Thank you for the great program and informing us about the Tucson meeting, because I just registered for it.
Great.
I'm in Tucson. I just arrived here Monday, but I live north of Seattle, and at least one Jen Vanderhoof is on here right now too. And I made a film of beavers up there set up trail cameras and cutting trees and gnawing the cameras 3 feet from this one, cutting a 6 or 8 inch log. And it's really fun. But anyway, it's really been fun. I learned a lot today, and I hope to learn more on Friday and also tonight. Thank you.
And that Tucson event they're having an in-person portion to that. Actually drink beer. Okay, Michael.
I just, somebody was talking about the lowlands in the old country, Holland, and how they're actually addressing it in general is they're building, one way they're doing it that happens to deal with beaver is that they're building really mega structures, what we would call dikes. They're more building like hills, and they're really going, they're just dealing with it at a different scale. So they're building highlands that are so wide, they're actually putting structures on them and things in some cases. But the ones I've seen pictures of, I haven't been there, they're so large that beaver wouldn't really present any sort of structural problem. So it's really just kind of creating a sort of large geomorphic feature that's very durable and functional. And you don't even notice them because it just seems like a rise, it just seems like a natural hill that's somewhat linear. So anyway, it's kind of cool, but they're taking this seriously because if they don't, they're not going to have a country. They'll have a bathtub for a country, I guess. But anyway, yeah, there is a lot of really innovative stuff in fish passage and just maintaining below sea level or certainly below high tide structures or lands and such. So there's a lot of really good innovation coming out of them. And they're also in the forefront of some of that stuff I mentioned about really kind of terraforming deserts and trying to create lush oases out of desert regions. So a lot of good thinking coming out of that country.
Great. All right. Is this the Larry Santoyo?
It's a Larry Santoyo.
Is it the one I know?
How are you doing, Brock?
Okay.
Hey, I've got a question. I'm over here in Hollywood, Tongva land, and it dawned on me that some of the shelters look like beavers built them. What was the definitive? I kind of joined late. There was somebody talking about the ranges, historical ranges. I don't know about Pleistocene, but I know we had giant beavers in Los Angeles. What is the definitive or the common opinion about west of the Colorado River, in the Southland, like, Cleveland National Forest all the way down to the coast?
Definitely had them.
Yes.
In fact, you still have them. I'm not sure exactly of my geography there, but we got beavers in San Diego. We got beavers down below San Diego right now.
All right. And was there agreement on historical evidence of that, or are those known to be introduced or recently, or what is that? I've always said that beaver populated, when the redwoods couldn't harvest the moisture in the summer, the beavers did. So, from San Luis Obispo down.
We have skull proof of beaver in Santa Barbara, and
That's what I thought. Yeah.
Yeah, beaver in.
There you go. I'll continue with the tale then. Thank you.
Well, so Larry, I would just, you might have missed Dr. Rick Landman's talk, and these are recorded and they'll be online tomorrow. And he spoke about a series of papers that himself and Heidi and Kate Lundquist on here, myself and others published about this. And we can send you links to those. So there's a coastal.
Oh, that'd be great. Yeah, I think that would be great. I think I joined right as that was concluding, and I never really heard the definitive, just that it wasn't included in the earlier, reports, and then there was evidence thereafter. So anyway, I appreciate it, and I've enjoyed the entire show, and I hope I ditch work on Friday again and join you guys.
Right. Yeah. Ditch work by digging, at least dig the ditch on contour if you're going to ditch the work. All right, Peter, you want to ask us a question here?
Yes, I was curious about legal strategies for fighting the California law against translocation. I wonder if civil disobedience is something people have thought of as a way of starting a court case and seeing where it would go, and any other strategies for making that happen.
Yeah. Hey Duke lives. You could, I guess, do the Beaver first after their first. Mhm.
But has nobody tried that? Just bringing Beaver in against the rules and
I believe most of us on this call have to take the fifth on answering that question while Marjorie keeps her. So yeah, Black Ops Beavers is not a subject we're publicly speaking about right now, so I don't know.
Well, the last I heard was that if you move a beaver and you are then liable for whatever monetized damage that beaver does within that watershed. And so that can be quite a disincentive to move a beaver.
No, see, I would like it if we would do a legal challenge that was exactly the opposite. If you remove a beaver, you could be legally held liable for whatever good that beaver would have done to all the neighbors and all the residents and all the people who drink water in the city.
We're very poor at monetizing ecosystem services. They're invisible largely, and they're not human labor, and so we're very bad at monetizing that, unfortunately.
Yeah.
I will talk more about this on Friday, but the reality is we do have some rules that are changing within the department. Right now, the department, we're in conversation about some changing of the code about depredation permits in particular and how they affect listed species. And there is also a case that was brought against APHIS, which is the Animal Plant Health Information Services, that is the wildlife services that removes problem animals on behalf of our landowners. And so that case, as a result of them being threatened to be sued by the Center for Biological Diversity, they are now having to consult with NOAA and the National Marine Fisheries Service to basically make sure that by removing those beaver, that they are not, that action is not resulting in the death or incidental take of listed fish species in this case. So that could set a precedent for at least one segment of species. But otherwise, I mean, as far as I understand, there's a fine that you could get charged for, it's illegal to possess or move beaver. And otherwise, yeah, I don't know. I mean, at this point, most other states are resorting to legislative action or working with the department to come up with a pilot to adopt a relocation program. And I'll talk more about that on Friday.
All right, I got Scott up next and then Todd.
That was an interesting discussion. Probably most of you understand that there's a lot of issues with the habitat. If there aren't BDAs or things like that to give them some shelter, that they're likely to be predated. But there was a case out by Flaming Gorge Reservoir. A guy brought a bunch of aspen that he had cut down. He must have known what he was doing, and he released some beaver, and then they were able to build habitat. But that would be the exception rather than the rule, I would think. My question is a little bit different. I was wondering if anybody has experience with beaver and acid mine drainage, abandoned mines, or even near Superfund acid mine drainage. I know that beaver are pretty tolerant to low pH. and just in terms of having series of smaller catchment basins rather than, your typical larger remediation efforts.
Emily, are you online? Because I heard you talk about a great study a while ago about testing the effect of beaver dams on mine drainage. Basically, they looked at several different dams, and that as you went down the water from one dam to the next dam, the pH level kept dropping and getting better because of the beaver dams actually treating that.
Yeah, again, because the sediment in the pond floor quite often is very, very small, the cation exchange potential is huge. And so those soils are really good at absorbing all kinds of dissolved nutrients in the water.
Wow, beavers on acid. All right, Todd.
Yeah, I just wanted to figure out, I'll wait for Friday for Kate to tell us who we should lean on in the state legislature, but as a significant landowner on the San Mateo coast, like, since I can't transport beaver, what can I do to encourage them to come over the hill from Silicon Valley?
They're not far from you, and I think that we are really underestimate how much they will make their way. Yeah.
Todd, would you mind just at least telling us what watershed on the San Mateo Coast, Pacific side, you happen to live in?
Yeah, so it's the Princeton Harbor watershed north of Half Moon Bay. And I'm like, okay, I get that they're close, and I love that. I'm so excited. But without transporting them, which I don't want to get Marjorie in trouble, what can I do? Is it BDAs? What is it that I can do to hurry that up?
Plant willow. Make the habitat agreeable. Talk to your neighbors. Teach them how great beavers are so that when they show up, they don't get killed by their neighbors first.
I'm covered in willow. I'm covered, like, I have the best thing. It used to be a stream that everyone fished in year round, and now it's wet 3 months a year.
You
The
are
horse farms uphill. And I'm like, but how do I get them here if I don't want to violate the law, which would get Marjorie in trouble? So what do I do?
You're going to listen to Kate on Friday, and then we're going to just continue to push this process of legalizing beaver through these methodologies forward. So
We're gonna exploit the fungibility of state legislatures to get them to allow us. Is that right?
I've thought for years that we should just crowdfund a couple of suitcases and put them on a couple of desks and solve a whole bunch of problems in one shot. But I've just never quite figured out the actual, the logistics of that are a challenge, because I'm rarely in the capital if I can help it. I'm always out in the middle of nowhere.
Yikes. All righty, Ariel Greenwood, hi from New Mexico. What do you got for us?
Hey there. This has been so informative. My question is, I'm sure it's an it depends kind of question, but if some of the panelists could describe in California, let's say Coast Range and West, let's say you're starting with a creek that's totally denuded, and how much vegetation, let's say willow, how much do you need to support, say, a small beaver colony or whatever the kind of pioneer, maybe be a pair? I know it's hard to give any hard and fast answers, but I'm just trying to wrap my head around that kind of thing.
Check out the grant tool. It's got some great hard and fast answers about habitat.
Ariel, I could also add to that, the folks that do a lot of beaver relocation in Washington, for example, the Medhow Beaver Project, they have a scorecard that they use to assess the suitability of habitat before they release the beaver. And they're really looking at whether or not there are dozens of stems versus hundreds of stems within a 30-meter range of the waterway itself. If you've got hundreds, then you're good. If they're further out than 30 meters, unless it's a really exciting, enticing species like aspen, which beaver will risk their lives for, they tend that's less favorable. And so that's kind of a good just baseline benchmark. Heidi, I don't know if you were saying check out the BRAT, but the BRAT for California, just so everyone knows, it's using vegetation data that's really coarse. And so those pixels that model is based on are like 30 meters wide. And so it doesn't always pick up densely vegetated corridors. And so you have to actually kind of do a little bit more diligence to look at the vegetation and zoom in through remote sensing or get out on site and see what the vegetation likes. But making sure that it's the kind of species that beaver really favor. Jeff, I think, really explained that really well in terms of the bulbs, the grasses, the corms, like all of those vegetative plants, and then the deciduous, the willows and cottonwoods and aspen and poplars, they're going to go for as well. So that's what
and I guess we're reading in assuming that we've got perennial water or enough perennial water that if we could help them with a starter BDA or a dam, we can get enough depth depending on if you've got winter and it freezes or not, and how do we keep the mountain lions out of their claws or not. And so that's the scorecard that Kate's talking about. Is it's a comprehensive look at the fluvial geomorphology, vegetation, slope, widths, predator, there's the whole package deal on what we would consider to be the suite of viability. Yeah. All right, Muriel, hi, how are you?
So this has been totally awesome. And as it happens, I noticed that the discussion kind of hopped over flyover country. And as it happens, I inherited some farmland in Iowa. And so I'm looking around to see how to set it up for when I'm gone. Now there's a land trust, there's Iowa Natural Heritage Society, but it's a whole different ecosystem out there. And setting aside the whole issue of the corn, soy, conventional farming, and the pesticides and yada, yada, it's flat, like so flat. And everything's tiled. Now I've found that the land that I have is what they call prairie pothole. And so it's relatively sloped. I mean, there's a couple of areas on the land that if I really wanted to farm it and make money, I would have it tiled there, but I don't want to do that. And because those particular areas that are low, anyway, so I noticed that there's one practitioner out there in Iowa, so I'm going to be following up on that, but I just wanted to kind of raise those other issues, plus which the whole problem of nitrates and phosphate in the drainage in Iowa that goes down to Mississippi is also a big deal. And, what are the possibilities that, Beaver Pond could address that, but at the same time, they want the drainage because it's so flat. So it's a bit of a Gordian knot, but I just wanted to kind of raise those issues from flyover country.
Right. Well, those are good issues. I don't know. I was in Iowa this last fall, and I saw some, the Iowa River, actually. I saw beavers and bald eagles and all kind of cool stuff out there. Now, it wasn't pothole country per se in that section, but yeah, less corn and soy and more beavers and bald eagles. That's Iowa's recipe for sure.
I feel like if there's anything I've learned in all these years, it's that never give up on the resiliency of the land and the ability to recover from all the things we've thrown at it. So I feel like if you worked with someone and did a little love to keep some of the water on the land and let the soil do some work and grow some plants, you could see some amazing things happen.
Mira, ping me later and we'll talk about this amazing permaculture center that's restoring these incredible tall grass prairies along the Iowa River out there that we visited as part of a hip camp that we stayed in. Really fun.
Brock, it looks like you're muted.
Bradford, did I let you get in? All right, Bradford, you're up. Nope. Just went away. All righty, team. I don't see any hands over there in the attendees world. Not seeing any new questions. Oh, somebody wants the habitat scorecard. Maybe Kate can post that. All right. Well, it's time to move on. Anybody else got anything you want to share?
Looks like there's a hand up again from Bradford Smith.
Yeah, seems like Bradford's kind of in and out. All right.
Hello, can you hear me now?
Yep.
Can you hear me?
Yep.
Okay, it dropped me for a second. I'm driving from Oregon back to Santa Barbara. Great to hear Larry Santoyo. I learned about permaculture 20 years ago from Larry. I learned about sustainability at Fairlawns Institute 40 years ago, where LAAC is now. Quick question, is there a fund for legalizing? I just learned today, I'm a Beaver believer as of today, and it shocks me that California is maybe the only place you can't, transport and reestablish beavers. So is there a fund that I can donate some of my limited funds to do a serious legal challenge or something, or Sacramento effort?
We're happy to talk to you offline, Bradford. I know OAC and with Heidi, and we're involved with the Center for Biological Diversity right now, and EPIC, the Environmental Protection Information Center. We're in an engagement with California Department of Fish and Wildlife right now, and the Fish and Game Commission about various things. And so, if you want to chat us up, and for those on the call who don't recognize that Bradford's talking about the Fairlawns Institute, the property that the Oxnard Ecology Center is on, used to be the Fairlawns Institute in 1974 up until 1990. So we're carrying on with the legacy of that work. And Larry Santoyo and I have been teaching permaculture on and off together for 25 years now as well. So Mira, who was just on, was in a permaculture course of ours.
Yeah. And I'm inspired by Larry. I did a workshop with Larry 20 years ago on community building up at Harbin. If you're there, Larry, if you remember that. And I'm in the process now of finally moving to Lost Valley Eco Village. And we got Antonio Creek going right through us. So we'll see what we can do there, I hope.
Well, if you're coming from the Beaver State on your way to Santa Barbara, throw a few in the trunk and just liberally sling them off the bridges as you head south. Nobody will know.
Yeah. Thank you.
Okay, people. Oh my goodness. Now we got more hands. All right, Catherine. Catherine Perkins, you're up. Catherine, can you get on?
Can you hear me?
Now we
Can you hear
can.
me now? Yeah, sorry about that. Thanks so much for taking my question and for a great day of talks. So awesome. I am working on a planning project, designing naturalization of a creek confluence, a naturalized creek in Sacramento, where beavers moved in and transformed it from a creek to a series of beaver dams. And we're working on naturalization of the confluence with the creek and the American River. And I'm wondering if there's any advice that folks have for confluences, naturalization projects. Kind of a vague question, but figured I'd throw it out.
Hmm.
Is this in Rancho Cordova? Sounds
Yeah,
familiar.
Kevin, we've
Yeah.
talked of it. Yeah.
Yeah. It looks amazing out there. Those beavers are totally riding. They're having so much fun.
Yes. Let it be. Let them do what they will with the naturalized confluence, deciding between more of a just kind of straightforward connection and meandering pathway. Just kind of let them do what they will, or
That's an interesting one from the restoration perspective. I mean, obviously I don't do the form-based construction, but if I remember correctly, the outfall there is super, super steep right now.
Yep.
Drops like what, 8 or 10 feet in 100? What are you thinking of doing?
Well, we're kind of trying to decide on whether to keep the existing alignment and just take out some of the concrete, or kind of reroute, make it a little longer. There's benefits to both sides, you know. There's a lot of questions about salmon suitability right now, and passage and juvenile passage. So sorting through all of those questions. Yeah.
Are you hoping to get them up into the channel you guys built that's got the beavers in it, or what's the?
Yeah, people are kind of trying to decide whether or not that's a good idea right now. You know, it's hotter than the main channel, so it might not be real suitable for salmon all of the time. But right now it's so steep that in dry years there's no hydrologic connection. And you know, it looks like there could be benefit sometimes to having fish there, and at least a choice of whether or not to come up or not.
Hey, Catherine, this is Margie. I think it would be worth talking to our Region 2 biologists about the value they see in that stream, and what the database, the BIOS database, says about salmon in there. And you know, if it's something that the regional biologists are interested in, you know, certainly the department's engineers and geomorphologists could come out and take a site visit with you and take a look at and brainstorm with you. So if you want to send me an email, I can get you connected with the right person.
Great. Oh, thank you so much, Marjorie. I will definitely take you up on that. Been talking to CDFW scientists, and there's varied opinions. So I will definitely take you up on that. Thanks so much.
No problem.
And Catherine, this is Karen Pope. Oh, sorry, I don't have my video on. One thought is a colleague of mine is a fish modeler, population modeler, and he does a lot of work with fish passage and modeling populations. And there are some restoration projects that are done to encourage fish passage, and a lot, you know, sometimes that results in fish passage to places that fish shouldn't go, and so you get ecological traps happening. And so California is all about fish passage, but it isn't necessarily the biological best thing to do for fish. So that's something to be to consider. And then also I would ask if you have LiDAR for the site.
Yes, we do actually. Yeah, and I guess the ecological trap question is kind of what we're trying to figure out right now.
Yeah, I mean, if you were willing to share the LiDAR for the site, I could have a couple people play with it and maybe pass it to our fish modeler and see what he has to say.
I'd love that. Thanks, Karen. I'll send you an email if that sounds okay.
Muriel, you're back in.
Hey, Catherine, I just wanted to share with you some information about local advocacy groups. That's the Save the American River Association, and Betsy Wieland is their spark plug. And there's also the Environmental Council of Sacramento, and they're very much interested in habitat and stuff like that. So I don't know, you know, exactly what their technical chops are, but if you want to connect with people, grassroots advocacy, you can find them just searching online, Save the American River Association and the Environmental Council of Sacramento, not to mention the Sierra Club and so forth.
Thanks, Muriel. I work at the Water Forum, and we are in touch with some of those folks. Betsy's been great to talk to about this program. You're absolutely right.
And I would just say that it's not an area that is beaver savvy, I don't think. So I think you're not preaching to the choir. Whatever you do, people are not going to have the best opinions of beavers and their role in that particular area.
But I will add to that that is changing, especially the American Rivers Conservancy has been supporting a lot of coexistence strategies. And so we held a talk there for all the agencies, and we had a lot of folks attending. So there's an interest that's starting to shift, which is great.
Yeah, in the couple years that I've been working on this project, it's went from the kill approach to coexistence to co-engineering. So it's been really awesome to see that.
That's great.
Righty, Brad.
Hi there, thanks, Brock. Many years ago, I was involved in a restoration effort on Kimball Island, which is in the Sacramento-San Joaquin Delta. And the problem out there was the wave action was tearing up the shoreline and causing a lot of erosion. So one of the solutions was to armor that area facing the channel, but also to plant willow stakes in among the armor, and of course, and inland just a little ways. And we knew there were beavers out in the delta, obviously, and on Kimball Island, but the island is full of arroyo willow. There was yellow willow out there, sandbar willow. It was teeming with willow, so nobody thought it would be an issue to plant some new willows there. And the beaver took a liking to the newly planted willows, and in the short term, it made everyone mad at the beavers. And so I'm wondering, and maybe this was covered earlier, I kind of jumped in a little bit late. What are some of the things that restorationists can do to work collaboratively with the beavers to sort of foresee some of these eventualities and then plan for them, rather than be in this constant reactive mode where, okay, now what do we do?
Well, if you wear the beavers around as hats, you don't have to worry about them eating your restoration plantings. So you start with fashion and work back to restoration.
That was suggested, actually.
Yeah, I bet. Well, Catherine, I mean, how many of your plantings got eaten on that Rancho Cordova job? I saw a bunch that had been chewed off. Yeah, it's a classic issue that you run into all the time. I think overplanting, if you're going to do a restoration project, go totally nuts and overplant the heck out of it. Consider temporary fencing. I mean, I don't really like to see fencing and irrigation down in restoration projects because it just turns into trash. There's never a budget to come pull that stuff back out. But if you set it up explicitly as temporary fencing, give them a little time to get up to size. You know, all your riparian species are beaver co-adapted for that 5 million years that Michael was talking about. So if you're planting food species, make sure they can't steal them until they're up to size. And if you're planting non-food species, space them back from your riparian corridors enough that the beavers aren't going to be incentivized to go get them for building materials. And you can also phase your plantings, you know, put in a bunch of food fenced off, let them get fat. then let the beavers have it that and come in and plant your more upland species on the edges where they're not going to be going after them. And yeah, just the folks that are doing this that you're in contact with, or if you're part of a team or whatever, just tell people, hey, you might have beavers here, and get folks thinking about it. Yeah, your comment on, being proactive versus reactive, I think is really key, because planning for them, you can get amazing success. Fighting against them, you're just going to burn a bunch of money and get mad at the poor critters.
Many of us in the permaculture field are fond of the phrase that planning is best done in advance. And so have a look at the system, figure it out, plan for the eventualities, see beaver as an ally, adapt accordingly, and then go forward. Nothing worse than a bunch of pissed off people because their precious willows got coppiced by a beaver, when in fact that's what the whole point of the restoration was. All righty, people. It is 6 o'clock. I got no other hands up. Everybody here gets the extra Beaver Believer Award for like sticking it out. All you 81 participants out there, plus Heidi and Karen and Jeff and Kate and Kevy and Jackie. Great work today, people. We're gonna see you Friday.
Right on. Thanks so much, everybody.
Right.
Bye.
Take care. See you Friday.
Hey, bye.
This is wonderful. Thank you, everyone.